On the 5th of November 2005, the Paleontology Documentary series Walking with Monsters was released. The final installment of the revolutionary and critically acclaimed Walking With series. As its subtitle states, Walking with Monsters, Life Before Dinosaurs, or Before the Dinosaurs, Walking with Monsters as it's called in North America, details the extinct organisms of the Paleozoic era from before the age of the famous reptiles. It was created by Impossible Pictures and produced by the BBC. Like the two other installments of the main trilogy, Walking with Dinosaurs and Walking with Beasts, its format is essentially that of an extinct nature documentary following the lives of extinct animals. This was done by having a camera crew film environmental backplates for the creatures to later inhabit, brought to life through CGI by the animation company Framestore, and through puppets and animatronics created by Crawley Creatures. Whilst chronologically taking place first, it was the third to be produced of the Trilogy of Life, as it's been dubbed, ending with the evolution of the dinosaurs, essentially bringing the Walking With series full circle. Whilst Tim Haynes, the creator and heart and soul of the Walking With series, was heavily involved, television writer, producer and director Chloe Leland was brought on as a producer and directed the first two episodes, with Haynes directing the third. Surprisingly absent is the second main driving force behind Walking With, Jasper James, who apparently had next to no involvement in Walking with Monsters. It's possible he was busy working on Impossible Pictures' next project at the time, Prehistoric Park, which was released only 8 months later. Due to the creatures of the Paleozoic being far less well known to the general public compared to dinosaurs and a handful of extinct mammals, in addition to many being more, quote, fantastical, Leland wanted to use the CGI to make the creatures feel more believable by making them interact with the camera more and using CGI more for close-up shots rather than puppets and animatronics like in previous shows. This was also an ode to the advances in the technology since making Walking with Dinosaurs back in '99. They did an amazing job as the effects look incredible even today, and I'd argue they're the best in the Walking With series. Monsters also has the most CGI creatures of all the shows, apparently numbering a whopping 29 animals, though I'm not sure which animals they did and didn't count, as I've counted as many as 31 or as few as 24. Whatever the number, as to be expected of Framestore, they all have wonderful textures and colorations and are animated beautifully. Like Walking with Dinosaurs and Beasts, Monsters is narrated by actor Sir Kenneth Branagh, and his delivery is wonderful as always. Unlike Dinosaurs and Beasts' 6 episodes, Monsters instead has only 3 episodes, focusing on multiple key moments throughout the Paleozoic era, and transitions between these moments within an episode with awesome evolution sequences, showing one species morphing into another over time, but I'll talk more about those later. Whilst the show is split into 3 episodes, I'm going to be going over all of them in one big video, as the show's structure links many of the time periods. Episode 1 has a prologue intro sequence in addition to 3 Paleozoic time periods, the Cambrian, the Silurian, and the Devonian. Episode 1 ends transitioning to the first of 2 sequences focused on in Episode 2 with the Carboniferous and then the early Permian. Episode 2 similarly ends transitioning to the first sequence focused on in Episode 3 with the late Permian, then the early Triassic, which is actually in the Mesozoic era but still before dinosaurs evolved. It's kind of ironic that the Paleozoic conveniently consists of 6 geological periods, yet it's the only show in the trilogy to not have 6 episodes. With that said, there actually exist 2 cuts of Walking with Monsters. One is the episodic cut, and the other is the Reader's Digest cut, which is in omnibus format, blending all the segments together into a single 90-minute documentary film. This cut actually has exclusive scenes and narration, and I only found out recently that it aired a month before the episodic cut did. The omnibus version aired on BBC 3 on the 5th of November 2005, whereas the 3 episodes aired a month later on the 8th, 15th and 19th of December respectively on BBC 1. The omnibus cut feels like the complete version of Walking with Monsters, but they may have felt that 90 minutes was too long of a runtime for people to watch in one sitting, especially when all the previous shows had been in episodic format, so gave Monsters the same treatment when airing it on BBC One. I am glad that the omnibus version was released in some capacity both on TV and the Reader's Digest DVD. I assume they aired it on BBC Three earlier, as it would have a lower viewership compared to the much more popular and mainstream channel BBC One, and to avoid potential backlash for the format being so different to the other shows, but that's purely speculation. Regarding the show's title, Walking with Dinosaurs was primarily about dinosaurs, and they're a household name, so was kind of a no-brainer decision for the title. Walking with Beasts was mainly about mammals, and the word beast is usually associated with mammals, evidenced by many mammal species' scientific name ending with therium, the Greek word meaning beast. Whilst I'm not a fan of the word monster being applied to real extinct animals, since it literally means frightening imaginary creature, I appreciate that they need to sell the show to people with a cool sounding title. There's also no single group that was most prevalent in the Paleozoic, so the more generic monsters works well as an umbrella term. Without further ado, let's take a look at Walking with Monsters 20 years later. The show opens with a completely computer-generated prologue sequence of the early Earth from space 4.4 billion years ago. Known geologically as the Hadean Eon, it is very appropriately named after Hades, the lord of the underworld in Greek mythology, as Earth likely looked much like a depiction of hell at the time. The narration fittingly describes it as a toxic world with no hope of life in the episodic cut. Whilst there are a few theories about how conditions became hospitable for life on Earth, the most accepted is the giant impact hypothesis, which is the one Monsters chooses to portray here. This theory hypothesizes that during the Hadean, around 4.6 billion years ago, when the solar system as a whole was in its infancy, it was a much more crowded place than today. The planets are thought to have formed due to vast amounts of debris created by and orbiting the newborn sun, being drawn together and colliding due to gravity in a process known as accretion, gradually growing into larger, more stable worlds. Roughly 4.5 billion years ago, Earth was struck by another planet, roughly the size of Mars, named Theia, after the Titan from Greek mythology who was the mother of Selene, the goddess of the moon, as the moon is thought to have been formed from debris from the collision caught in Earth's orbit, itself gradually accreting into a larger world. The show skips over a lot of the details and doesn't really explain how the impact made it so Earth would be able to support life. Understandably so, if you ask me, as it's a bit complicated and hard to explain with a limited runtime, and I imagine they wanted to get to the creatures as soon as possible. You'll have to forgive me, as astronomy, physics, and I guess astrophysics are not my strong suit, but I'm going to try my best to explain it comprehensively. Here we go. The most currently accepted hypothesis is the dynamo theory. Essentially, the collision would have superheated and melted much of Earth and Theia as the two early planets merged into one, greatly increasing Earth's mass and, crucially, the size of its core. As heat escapes from the solid inner core, it creates currents in the molten liquid outer core. As these currents pass by heavier materials like iron sinking into the core, they create convection currents. This geodynamo, as it's being called, forms a strong magnetic field which protects Earth's atmosphere by deflecting solar wind, kinetically charged particles ejected from the sun that would otherwise cause the atmosphere to be launched off into space upon collision. You can see this in action today near the poles. We call this phenomenon auroras. Because of this, the very thick, foggy atmosphere seen here may not be the most likely scenario for reconstructing Earth pre-impact. It is, however, a superb portrayal of the Earth's surface later in the Hadean post-impact when its magnetic field had formed. The The atmosphere at this time was likely yellow or orange due to the massive quantities of methane being ejected from volcanoes and within meteorites that struck the planet, a much more common occurrence in the more crowded early solar system than today. The omnibus cut shows slightly more of Earth's surface and has exclusive narration, showing meteorites flying across the sky on a collision course with the planet. You can also see giant red spots from volcanic eruptions from space, as well as lightning strikes and the sound of thunder from enormous storms. There was also a lot of water vapor ejected from volcanoes. Over time, Earth's molten surface cooled as much of its heat radiated off into space and its crust solidified. The plentiful water vapor then condensed from the lower temperatures, forming a liquid water ocean, a suitable place for simple life to evolve. Some of these single-celled organisms eventually evolved the remarkable ability of photosynthesis, using photons from sunlight to break down the dissolved carbon dioxide in the water, taking the carbon atoms to perform cellular processes and releasing the oxygen atoms as a waste product, releasing it en masse into the atmosphere, changing its colour from yellow or orange to blue due to the phenomenon known as Rayleigh scattering. I think that just about covers it. This sequence looks incredible, especially considering it has next to nothing to do with extinct animals, yet Framestore nailed it because they are masters of their craft. Even if the early Earth's atmosphere may not be the most likely for the time frame shown, the sequence ends with the moon going across the screen, transitioning into a montage of the various creatures we'll see throughout the show, similar to Walking with Beasts, before we get to the title sequence. I must be completely honest, I'm not a huge fan. It feels a bit overwhelming and in your face in the visuals. The red background and filter over the various creatures, combined with what I'm assuming is erupting lava, feels a bit overly dramatic for my liking, and so does the music. Speaking of, despite Monsters being composed by Ben Bartlett like the other Walking With shows, minus Cavemen, I'm inclined to say this is probably his weakest work in the series, at least in my opinion. The main theme, and in fact the entire soundtrack, feels very generic to me, at least compared to the other shows. It's not bad or anything, I just can't remember a single piece of music from Monsters' entire soundtrack, aside from the main theme. I do, however, like the title appearing on the sail of an Edaphosaurus, that's a cool touch, before a Brontoscorpio stings the screen, smashing it to reveal the episode. Don't get me wrong, it's really cool looking, I just much prefer the slower, more grand, imposing intro of Dinosaurs, and the high-energy, animalistic sounding one of Beasts. After the titles, Monsters makes the creative decision to skip over most of the Precambrian Supereon, jumping to the beginning of the Phanerozoic Eon, and by extension the Paleozoic era, which I think was a sensible choice, as life during much of the Precambrian was only cellular and microscopic, so not the most exciting thing to watch. In fact, the period spanning 1.8 billion to 800 million years ago has been colloquially dubbed the boring billion by some geologists, as there was seemingly little tectonic, climatic or evolutionary activity. The first segment is set in the first period of the Paleozoic, the Cambrian, 530 million years ago. The on-screen stats first seen in sea monsters at the start of each time period return here, and I still have mixed feelings about them. Whilst I think they could have just explained all the info shown with narration, both this show and Sea Monsters have multiple time periods seen within each of the only 3 episodes, so they're convenient for the faster pacing these shows have compared to the single time period seen across 6 episodes in Dinosaurs and Beasts. The place stat is self-explanatory. This segment is set in Chengjiang, China, though I'm pretty sure they missed out the I in Chengjiang, and is based on fossil finds from the Maotian Shan shales. I'm impressed they didn't go for the more well-known Burgess Shale of British Columbia to portray the Cambrian, so bonus points from me for the more obscure creatures. Unfortunately, we immediately have a chronology issue, as 530 million years ago is older than the Chengjiang biota, which is dated to roughly 518 million years ago. The oxygen content stat is cool, and it's interesting to see it gradually rise over time, but like in Sea Monsters, I feel like the hazard stat just kind of spoils what you're about to see, but maybe I'm alone on that. Where the filming locations are concerned, whilst I'm not certain, this looks quite similar to Cofete Beach in Fuerteventura in the Canary Islands, which have been used many times for filming these shows before. I'm unsure of the underwater filming location though. If you know more than I do, please do let me know in the comments. In the Cambrian, the continents of North America, Europe and Asia as we know them today hadn't formed yet. They were separated into a variety of cratons, ancient dense chunks of continental crust often found near the centres of tectonic plates that undergo very little change during continental drift. The South China Craton straddled the equator and was actually attached to the supercontinent Gondwana, which stretched from the equator to the South Pole, with almost the entire northern hemisphere covered by the ancient Panthalassic Ocean. The narration briefly mentions how nothing yet lives on land, but in the ocean, life has been evolving very slowly for millions of years, the majority of which was only single-celled. But that life in the shallows has stepped on the accelerator, which I imagine is referring to the Cambrian explosion, an observation of almost all major animal phyla rapidly appearing in the fossil record in the Cambrian. Critics of the explosion theory have suggested it to be a case of sampling bias, i.e. people have just happened to find far more fossils from a certain age, or those organisms lived in an ecosystem more prone to fossilization. The oldest evidence of multicellular animals is dated to the Cryogenian period, aka Snowball Earth, roughly 650 million years ago, based on the presence of the organic molecule 24-IPC, which is produced by sponges, and indeed, sponges, which make up the phylum Porifera, are thought to be the basalmost group in the animal kingdom, though some studies find ctenophores, aka comb jellies, to be at the base. After the melting of Snowball Earth thanks to volcanism, animals were able to diversify in the following Ediacaran period, and is potentially where many groups of animals actually originated rather than the Cambrian, but this remains unclear. Speaking of, we see a smack of jellyfish. I swear I'm not making that up. Live acted by, I think, modern blubber jellyfish, but I could be wrong. As the narration implies, the phylum Cnidaria, which also includes the sea anemones and corals, first evolved in the prior Ediacaran period roughly 580 million years ago, with the true jellyfish that comprise the clade Cyphozoa evolving in the early Cambrian roughly 538 million years ago. No fossils of Cyphozoans are known from the Chengjiang biota, but we know they must have been around at this time since they're still around today. Whether they look like this is unknown. The Maotianshan is thought to represent a shallow tropical sea, and this looks to be a shallow rocky reef, which feels like an appropriate ecosystem, as coral didn't become a major reef builder until the following Ordovician period. On the sea floor, we are quote-unquote introduced to our first computer-generated creature. I say it like that as the narration doesn't even identify it by class name. Some of the other Walking With shows would sometimes be very vague about naming creatures, but for whatever reason, Monsters is particularly egregious about this. As far as I can tell, it's for no good reason other than to make it easier for the audience to grasp what kind of animal it is, I guess, without giving them another complicated name to remember. The narration IDs it only as an arthropod, another major animal phylum that includes insects, arachnids, myriapods and crustaceans, as well as several extinct groups. Their signature feature is their chitinous exoskeleton that acts as both structural support, allowing them to grow stronger and faster with jointed legs, and to act as armour. I'm shocked that the narration didn't even ID it as a trilobite, an extremely successful and diverse class of marine arthropods that lived on the seabed and fed on detritus, that first evolved in the Cambrian roughly 520 million years ago, another point against the 530 million years ago setting, and persisted until the end of the Paleozoic era, 252 million years ago. So common are their fossils that they're used as index fossils, fossils used to determine precise geological dates from the presence of certain trilobite species in rock layers of different ages. Like the other shows, Walking With Monsters also got a tie-in book, sort of. Rather than its own dedicated book, Monsters was tied in with The Complete Guide to Prehistoric Life. It compiles almost all the creatures featured across all the shows with facts about them. It also has some scientific corrections and clarifications, be it from studies published after the show the creature was in aired, contradicting its portrayal in some way, or giving the names of the creatures that weren't given in the shows. With a few exceptions. Whilst trilobites do have a page dedicated to them in the book, this one isn't named anywhere as far as I can tell. It fills the role of a fairly generic trilobite, but if we're going to ID it, based on the Qingjiang genera found in the Maotianshan shales, it most closely resembles the genera Quanyangia and Eoredlichia, though if it's the latter, it's missing the long spine on its last segment. It has a wonderful green and yellow coloration. Sad it didn't get name dropped. A trilobite is then attacked by the so-called world's first super predator, which I'm guessing is the buzzword version of apex predator. The creature referred to as Anomalocaris. This animal's naming history is a bit convoluted. Its name translates roughly to unlike shrimp, as the first fossil specimen of this animal to be described was of what looked like the abdomen of a shrimp discovered in the fossil-rich Burgess Shale of British Columbia in 1892. In 1911, a strange ring-shaped fossil also found here was interpreted as a jellyfish and was given the name Peytoia. It wasn't until 1979 that a more complete specimen was discovered that showed that the abnormal shrimp was actually a frontal appendage of a larger animal and the jellyfish was a mouth. Whilst the original specimens were from two different animals, Anomalocaris and Peytoia were both found to be members of a bizarre group of early arthropods that would be called radiodonts in 1996. Running the length of their bodies, they had paired rows of segmented flapping appendages down their sides for swimming, presumably in an up and down movement similar to stingrays, which is recreated wonderfully here. Their most distinct feature was their unique frontal appendages. They were segmented and flexible, with a variety of shapes and functions across species, making them ecologically diverse. Anomalocaris likely used them for grasping prey and pulling them towards their circular mouths, which had several tooth plates that would likely move inwards to bite prey. Despite looking so alien, they have the familiar compound eyes seen in arthropods on stalks, consisting of hexagonal ommatidia, which contain their own photoreceptor cells. This is showcased in the first of several anatomical shots where we get a close-up view of certain adaptations the creatures have and are completely unique to monsters. This one uses a really cool hexagonal pattern lens to show the creature's point of view. The evolution of eyes and sight is thought to have been a major innovation in the Cambrian, as animals were now able to actively seek out food rather than hoping to happen upon it, and to spot potential predators. The Anomalocaris identity crisis doesn't end yet though. Despite being referred to the genus at the time as a sauron, in 2021 the Maotianshan specimen with the pair of long furcae on its last segment, as is reconstructed here, was instead referred to fellow radiodont genus Hucaris, and then in 2022 was given its own genus Innovationcaris, meaning innovation shrimp. This model is said to be about 2 meters long, which is longer than even the longest known Anomalocaris specimens. Innovationcaris is only known from a complete juvenile specimen, roughly 10 centimeters long, so it's difficult to determine how large an adult would be, but I'm doubtful it would be as large as this portrayal. Size aside, everything else looks to be correct, at least for the time. Since the show came out, many studies have been published doubting that radiodonts with raptorial feeding appendages like Innovationcaris and Anomalocaris would have fed on armoured benthic animals like trilobites, as this would have risked them damaging their appendages both against the tough armour of their prey and the hard substrate. Rather, they may have hunted softer, free-swimming prey higher in the water column. The cuticle of radiodont's armour is now thought to have been softer and very flexible, so the following scene where two Innovationcaris fight and one has their armour split from being bent too far is likely inaccurate now. though I do like the added touch of armour clanging whenever they collide. It's unknown whether these animals were territorial or if they fought, but it seems plausible to me that they would have from time to time. Radiodonts are also now known to have had external gills that formed rows of thin, hair-like strands down their backs, called cetal blades. The head region also would have had a protective sclerite on the front. The appendages also look like they're just stuck on to the underside of the head on this model, rather than being attached to the front. So yeah, this reconstruction is quite dated now, but for the time it was essentially perfect, and the colour scheme is simple but plausible as it's counter-shaded. That is, it's dark on the top and light on the bottom, to make it harder to see from both above and below, like many modern aquatic animals. And considering eyesight would have evolved in the Cambrian, these may have been some of the first animals to have this feature. It's worth noting that whilst Anomalocaris is called the first super or apex predator, it's possible this title belongs to the obscure genus Omnidens, described and named from Chengjiang in 2006. Its name means all teeth, as the only fossils of this animal are thought to be the tips of huge spiked mouth parts. The identity of this creature is difficult to pin down, but most studies favour a close relationship with both arthropods and their close relatives, the velvet worms of the phylum Onychophora. Its fossils are very similar to another genus, Pandalurion, which is more completely known and may even be synonymous with it, except that the Omniden specimens were huge, indicating an animal that could have been 1.5 meters long. Much larger than even the largest known Anomalocaris specimens, and likely the largest Cambrian animal known. It was likely the largest and apex predator of its ecosystem, but seems to have lived on the seafloor like an aquatic velvet worm, occupying a different niche to the free-swimming radiodonts, but it wasn't known about when the show was made. In the background, you can make out some weird sessile reef organisms. These aren't identified anywhere, and you never really get a good look at them. I assume these are meant to be generic sponges, as they were also used in sea monsters in the Devonian segment. The injured Innovationcaris is then scavenged by a shoal of Haiku-ichthyes. Its name means haiku fish, after the city of Haiku in Hainan, China, and as its name suggests, it is one of the first animals that could be considered a fish, as it is among the first vertebrates, which make them close to our own ancestry, as well as all other backboned animals in the phylum Chordata, which also includes the lancelets and tunicates. For Haiku-ichthyes, we see its primitive backbone reconstructed as a physical model. I'm not sure what materials they would have used to make this prop, but it looks good. Haiku-ichthyes is part of the order Miloconmingiida, along with other early vertebrates also found at Chengjiang at the very base of the vertebrate family tree, and was only 1 inch long. The model has really cool translucent skin where you can see the internal organs like with some modern animals. It's hard to spot due to the beautiful and elaborate coloration, but it correctly has the 6 to 9 gill pairs seen on the fossils, which is fantastic. It's correctly reconstructed without any pelvic fins and a connected dorsal and caudal fin. Whilst it had a skull, it lacked any jaws, and so was likely a suction feeder of detritus and a scavenger like is seen here. So yeah, this early relative of ours is basically perfect, and the texturing and colours look awesome. It's also really impressive just how many models are animated in this shoal. The narration kind of implies that Haiku-ichthyes, and indeed vertebrates in general, are superior to arthropods in that their endoskeleton made them more maneuverable, but this may be an artifact of the more rigid reconstructions of radiodont cuticles of the time. It also wouldn't be fair to say that vertebrates are superior, as arthropods are the most species-rich animal group on the planet today, and likely were at many points in the past too. So the Cambrian segment doesn't really have much of a storyline other than the Innovationcaris hunting a trilobite, getting injured in a fight and being fed on by Haiku-ichthyes. I don't really know how much story you could really get out of a Cambrian setting due to the creatures being so strange and otherworldly that it can be difficult to relate to their struggles. This is probably my least favourite segment to watch in Walking with Monsters for this reason. Well, that and the fact that they didn't name drop my boy Trilobite. As fascinating as they are, I think many Paleozoic animals are victims of charismatic megafauna bias, which is a fancy way of saying human brain likey big animal, because they're more exciting and end up being more popular with people. I might be paraphrasing a little bit here, but director Chloe Leland says in the behind the scenes that many creatures seen in Monsters lacked complex behaviours and emotional hooks for the audience, and so much of the impact of Monsters' storylines instead had to come from the adaptations and pivotal moments in evolution instead, which I can understand, and I think it was a sensible decision from a creative standpoint. I do, however, wonder how these stories and ecosystems might have been to watch if they were given a longer runtime. The Cambrian segment ends with the first evolution sequence, a huge highlight of Monsters. They portray one of the animals from the prior segment morphing into one of their descendants that features in the following segment, though put a pin in that for now. These are awesome. Framestore really went above and beyond with the CGI for Monsters, as the morphing animations look amazing. They have the texture and coloration of the starting and ending creature flash across the entire body as it morphs from one animal into another, and it's almost psychedelic to look at, but in a good way. The camera will focus on new bodily features and adaptations as they evolve over time, with the geological timer clocking forwards towards the next segment's setting in the top left corner. As pure eye candy as these sequences are, they, as well as the narration at times, may unintentionally be a bit misleading in that they somewhat frame evolution as having goals and newer organisms as being superior to their ancestors, when in reality they simply adapted to their ecosystems due to random favourable mutations over generations. We call this natural selection. It's also worth noting that it's almost impossible to trace precise ancestry with only fossils of organisms separated by millions of years, but using the term ancestors is more comprehensive, so just take it with a pinch of salt. We see the Cambrian Hycoichthyes evolve into a new kind of fish over a whopping 112 million years, although it would more likely be 100 million on the dot from what we discussed earlier, in the Silurian period, 418 million years ago, and oh boy, there is a lot to talk about with this one. So there's two things to note right off the bat. The first is that unfortunately the second period of the Paleozoic, the Ordovician, is skipped entirely in Monsters, though we did at least see it in Sea Monsters, so it at least has coverage in the Walking With series. The second is that, well, the third period, the Silurian, is also skipped entirely. Yeah, 418 million years ago would actually be the very start of the fourth period, the Devonian. So despite being called the Silurian, this segment is actually set in the early Devonian of Wales, possibly based on fossil finds from the, and you'll have to forgive me for not knowing how to pronounce this, St. Morgan's Formation, which at the time was thought to be dated to the late Silurian. At the start of the Devonian, the UK was located near the equator on the southeastern edge of the ancient landmass of Laurussia, also known as Euramerica, composed of fragments of what would become Europe and North America that had merged since the Cambrian. It was separated from Gondwana to the south and east by the ancient Rheic Ocean. I'm not certain of the underwater filming location, but it might be the same as the Cambrian, as it's again a coastal rocky reef ecosystem. Inhabiting this ecosystem is the fish Cephalaspis. Its name means head shield, and as its name suggests, it had an armoured head shield. Ever since it was first named and described in 1835, Cephalaspis has been a wastebasket taxon for various armoured jawless fish from across Europe and North America. It wasn't until after the show aired that a paper was published in 2009 that determined the only species that could be confidently referred to the genus was C. lyelli from the UK. Whilst this segment is set in the UK, due to the messy nature of the genus, I have no idea if this model is based on fossils referable to Cephalaspis anymore, but I'll assume it is for the sake of simplicity. At around 30 centimeters long, it was much larger than the fish of the Cambrian. Whilst the head shield looks spot on, The body is slightly too wide compared to the fossils. It still lacked jaws and was thought to have been a bottom feeder with its mouth located on the underside of its head, feeding on algae, detritus, or maybe even small animals in the substrate. I do quite like the bold yellow and green coloration it has too. I like that this segment then takes the time to look at some ancient examples of animals still alive today, such as sea urchins, which I think are live acted by modern long-spined sea urchins, but I could be wrong. Sea urchins are thought to have first evolved in the Ordovician period, as the oldest known fossils date to this period. The same sessile organisms from the Cambrian can also be seen in the background here, as well as strange floating bag-like creatures. These were in the Ordovician segment in sea monsters, and I believe they're meant to be graptolites, bizarre colonial filter feeders that evolved back in the Cambrian and, as of a 2013 study, are still alive today in the form of the genus Rhabdopleura. We are then reintroduced to the orthocone, also first seen in the Ordovician segment of sea monsters. The genus depicted there was based on specimens referred to the genus Camaraceras at the time, but have since been referred to Endoceras, both of which are only known from the Ordovician. Orthocone actually only refers to the long conical shell, and is seen in several unrelated groups in the cephalopod class, itself part of the mollusk phylum, also originating in the Cambrian. The narration describes them as distant relatives of squid and octopus, which is true, but their closest modern relatives are the shelled nautiluses. It also states that it is as long as a truck, which is kind of vague. Older estimates had total lengths of 9 meters for the largest Endoceras specimens, which is around the size seen in sea monsters, so I'd assume this one is of a similar size. Most of the giant orthoconic nautiloids became extinct in the mass extinction event at the end of the Ordovician, but some smaller forms persisted until the Triassic period, none of which even reached the revised longest estimates for Endoceras of roughly 5 meters long. I also can't find any fossil evidence of orthoconic nautiloids from the early Devonian UK, but it's plausible there were some in the area at the time, but they would not have been of this size, as they were no longer the ocean's apex predators. Like in sea monsters, this creature is accompanied by the calls of a cactus wren for whatever reason. I've also noticed there's some very faint whale calls used as ambience in this segment too. We are then introduced to Brontoscorpio. Its name means thunder scorpion, and oh boy, there's a lot to unpack here. This animal is only known from a single fossil from England described in 1972, interpreted as the tip of a finger of the pedipalp, aka the pincers, of a scorpion that was 10 centimeters long. The animal's total length was extrapolated from this single body part by comparisons with the proportions of modern species, giving total length estimates of 3 feet, which would make it one of the largest scorpions to ever live. However, modern scorpion pincers vary in shape, size and proportion quite substantially, so this is purely speculative. It has the correct 4 pairs of legs for a scorpion, the grasping pedipalps, and a long post-abdomen that forms the tail with a stinger at the end, which I'm not sure if they had venom yet at this point in their evolution. It seems to have an extra pair of appendages instead of chelicerae for their mouth parts, which I'm not sure is reasonable. All of this may not even matter though, as in 2024, a paper suggested the pincer fragment may not even be from a scorpion, but rather a crustacean. Brontoscorpio is so fragmentary though that any reconstruction is going to be extremely speculative, so I'm not sure if I can really meaningfully critique this model. I do like the coloration though, with a mostly brown body with speckles of blue, yellow and orange over the pre-abdomen. It also uses its stinger to crack the camera lens. Walking with dinosaurs would very rarely break the fourth wall like this. Beasts was a bit more liberal with it. Monsters does it a lot. And for me, the charm wears thin pretty quickly, to be completely honest. When it happened in dinosaurs or beasts, they were few and far between enough that when they did pop up, it would warrant a reaction along the lines of, that was a little random, but kinda charming, I guess. But Monsters does it so often and normalizes it to a point where I just see these moments and think, I get it. And it just kind of breaks the immersion a bit much for my liking. This, coupled with the narration often framing evolution in the Paleozoic as this war or race for our ancestors to take over Earth, are why I end up not liking the style and approach Walk with Monsters has as much as the other shows, but maybe I'm just being a stick in the mud about it. Interestingly, the Omnibus Cut has an exclusive shot of several Brontoscorpio with unique narration that states that scorpions are the top predators in the sea, which is kind of true but not quite, but we'll discuss that more in a little bit. Back to the show itself, a Brontoscorpio spooks a school of Cephalaspis before locking onto one in particular. We then get a close-up at the Cephalaspis' head shield with the use of a puppet, with the narration stating that they have evolved electroreception to detect vibrations in the water around them, and that we have inherited similar abilities with our sense of touch. Modern fish also have this in the form of the lateral line organ. After a brief chase, the Cephalaspis changes directions after quite literally picking up bad vibes that the Brontoscorpio is unable to detect and is ambushed by a Pterigotus. Its name means winged one, after its flattened paddling limbs. It was a Eurypterid, colloquially known as sea scorpions, despite not actually being true scorpions, but rather more closely related to horseshoe crabs, which themselves are a bit of a misnomer as they're not actually crabs. Eurypterids first evolved in the Ordovician, one of the first forms being the genus seen in sea monsters, Megalograptus. They survived the Ordovician extinction, and with the demise of the giant orthocones, went on to become the ocean's apex predators in the Silurian and early Devonian, persisting up to around the end of the Paleozoic era, with some forms growing to become the largest known arthropods. Whilst the narration says that Pterigotus is 3 meters long and the largest arthropod of all time, that title is currently held by fellow Eurypterid Gecalopterus at 2.6 meters long. The largest species of Pterigotus reached 1.75 meters long, still a large arthropod by any standards, but not quite the 3-meter Goliath seen here. This model is almost perfect. There's just one big issue. Eurypterids had 6 pairs of appendages. The first pair, the Chelicerae, were very unique in the family Pterigotidae, as they acted as scorpion-like pincers thought to have been used to crush and bring food into the mouth. This quirk seems to have been misunderstood by the modelers, as they've given it an extra pair of appendages on its underside, I presume thought to be normal Chelicerae, when these didn't actually exist. Pairs 2 to 5 were walking legs, and the 6th pair were flattened paddling limbs for swimming. It has the rounded and ridged telson, also unique to this family, thought to have acted as a rudder for swimming. This likely represents the species P. anglicus found in early Devonian Scotland from both marine and freshwater sediments. Both the Chelicerae and eyes of the Brontoscorpio model looked very similar to those of Pterigotus, so I wonder if the modelers based a lot of the unknown elements on Pterigotus rather than actual scorpions. It also has a very similar colour scheme, with a mostly light brown body with speckles of blue, orange and white spots down the back. Something that is a bit odd is that this female is shown to be a mother feeding the Brontoscorpio to her young, which contradicts the portrayal of Megalograptus in sea monsters as well as modern horseshoe crabs, which lay their eggs on beaches at high tide and leave them to be carried back out to sea again when they hatch. We don't know for certain what the parenting habits of Pterigotus were, but I think the safest assumption would be to go with what their closest relatives do. This is so close to being a perfect Pterigotus, but the extra pair of appendages makes it not so, which is such a shame as it's otherwise spectacular. We then see a school of Cephalaspis migrating to fresh water to breed. Fossils referred to Cephalaspis have been found in sediments preserving both marine and freshwater environments, but again, it's hard to say if these are still referable to the genus, or if they were anadromous like modern salmon that swim upriver to spawn. I'm pretty sure this inland desert river setting was filmed on the Colorado River in either Utah or Arizona, perhaps Lake Powell, but I could be wrong. It's perfect for a Silurian, early Devonian inland river. growing upon the scorching desert rocks are Cooksonia. Whilst the narration calls them the first pioneering plants, the first evidence for land plants actually dates back to the Ordovician in the form of microscopic fossilized spores. These, however, belonged to bryophytes, simple plants like mosses, liverworts and hornworts, that were limited to the water's edge as they lacked a way to encroach on the dry land away from water. Cooksonia was one of the first known tracheophytes, vascular plants, that is, plants with a cellular transport system for water and nutrients, supported by the organic compound lignin. It's this strong structural compound that allows vascular plants to not only form stems to grow upwards and larger surface areas for absorbing light for photosynthesis, but crucially root to grow downwards into rock. With slow and steady growth, roots could break down rock in search of subterranean water sources and nutrients, forming soil and spreading further from water, eventually covering the land in an event known as the Silurian Devonian Terrestrial Revolution, or more colloquially, the greening of planet Earth, pumping more oxygen into the atmosphere. The narration even foreshadows that the basic design of Cooksonia will eventually lead to forests. The show is understandably vague about the details of how plants conquered the land, as it's complicated to explain with a limited runtime. It wasn't just plants that conquered land during this time, however. Fungi were also pivotal as they formed symbiotic relationships with both algae, forming lichens, and plants themselves by forming essentially fungal roots for some land plants in exchange for sugars the algae or plants create via photosynthesis. Sadly absent is the enigmatic and charismatic Prototaxites, as it was not as well understood at the time the show was made. It is debated whether it was a true fungus or a lichen, but it formed huge towering bodies, essentially precursors to trees, and were without doubt the largest organisms on land during the Silurian and early Devonian before the evolution of trees. The exact appearance of Prototaxites, though, is still heavily debated. Back to Cooksonia, they appear to be practically made, but I'm not sure from what material. They look basically spot on to the fossils as simple bifurcating stalks ending with a spore-bearing sporangium for dispersal, presumably by wind. As the cephalaspis make their way upriver with a few cleverly reused shots with a green filter, the narration explains that they're able to do this because their complex brains grant them memory with an anatomical shot of a practical cephalaspis brain. I don't know if an endocast has ever been studied for the brain case of cephalaspis, but based on the shape of modern fish brains, this seems reasonable to me. However, the narration then states that scorpions like Brontoscorpio have no memory at all. Experiments carried out on insects have shown that they are capable of remembering certain stimuli, like smells and locations, so I'm very doubtful of this assertion. I feel like lacking memory entirely just doesn't make sense from a survival standpoint, as how else would an animal learn how to keep itself alive otherwise? The narration is then a bit too emotive for my liking, as it states that the cephalaspis have underestimated their enemies, as we see a group of Brontoscorpio coming ashore onto dry land, and it feels a bit anthropomorphic and unrealistic to me, and of course one of them lightly bumps the camera because monsters. Here, Brontoscorpio is portrayed as a primarily marine animal with amphibious tendencies, similar to many crabs today. The only fossil was found in sediments preserving a terrestrial environment, but other fossil scorpions from the Silurian and early Devonian are known for both terrestrial and marine deposits, so the amphibious interpretation seems to fit the data we have best. The narration also states that arthropods were the first animals to move from water and walk on land, which is true, but this scene could easily be interpreted as Brontoscorpio being the first animals to walk on land, which is not the case as there are both body and trace fossils of arthropods and possibly also a slug-like mollusk walking on a terrestrial tidal flat in the rocks of Blackberry Hill, Wisconsin, dating back to the Cambrian. Most likely this is intended as an allegory for the first arthropods on land, owing again to Chloe Leland's assertion of pivotal moments in evolution being monsters' strongest plot elements. I love the detail of their footsteps in the sand being washed away by the tide. We then get an anatomical shot of the Brontoscorpio's buck lungs, a unique structure to chelicerate arthropods like scorpions, used for gas exchange to extract atmospheric oxygen directly to their hemolymph, a fluid equivalent to blood in vertebrates. The internal buck lungs are thought to be derived from the external buck gills seen in their relatives the horseshoe crabs, for extracting dissolved oxygen in water. Based on modern arachnid buck lungs, this prop looks pretty spot on, as they really do look like book pages. The narration states that Brontoscorpio has both gills and lungs, but this is impossible to tell, and again, it might not even be a scorpion. The Cephalaspis make it to the spawning pool, but have to leap across a small ridge to get there, again similar to modern salmon. We see them lay eggs with what I think is the tail of a Cephalaspis puppet. Their eggs look like the orange roe of salmon too. The jumping fish are then attacked by the Brontoscorpio, who have happened upon them by chance. I know I've said it a lot already, but I'll say it again. Framestore did such amazing work. Just look at how perfectly the shadow is cast on the ground in this shot. It's interesting that Brontoscorpio are shown living in groups, or at least loose congregations, and hunting during the day, as most species today are solitary and nocturnal. I bring this up now as whilst most of them are feeding on the Cephalaspis, one Brontoscorpio is unable to eat due to it needing to molt its outer cuticle. This is done with a really convincing practical effect, as this huge scorpion sheds its old exoskeleton whilst growing a newer, larger one like modern arthropods. It does this on land under the heat of the sun in a really cool time-lapse, going from day to night, when I feel like a night-to-day time-lapse would make more sense to avoid the sun's heat. The next morning, the scorpion has missed his chance, as the Cephalaspis have left the pool and are returning to the sea. The segment ends with the narration stating that evolution is going to give our fish ancestors weapons to fight back, as Cephalaspis evolves into a creature with jaws and 4 legs. Now, there's a big issue here. Cephalaspis was not ancestral to us. It was an osteostracon, a group of jawless fish that evolved in the Silurian and became extinct at the end of the Devonian, leaving no descendants. Fish with jaws had actually already evolved by the Silurian, and our most likely closest ancestor from this time was the jawed Saurolepis from southern China. Its placement on the fish family tree has varied a bit since its description in 1998, but it has been consistently found to be an osteichthyon, a bony fish. Today, bony fishes consist of the actinopterygians, the ray-finned fish, which represent the vast majority of species today, and the group that interests Professor Nick Cutter the most, the sarcopterygians, lobe-finned fish. By extension, this group also includes all land vertebrates, as they're descended from lobe-finned fish. Saurolepis is most often placed as more basal than this split in the bony fishes, with the chondrichthyes, the cartilaginous fish, like sharks, rays and chimeras, branching off earlier. It's thought that jaws originated from the gill arches, the bony rings supported by cartilage that the gills are attached to, with the first pair mutating over generations to surround the mouth, forming the first jaw. A paper published in 2023 found that similarly, the pectoral fins and later the shoulder girdle supporting the forelimbs originated from the rearmost gill arch pair based on Colimaspis, an armoured-jawed fish from early Devonian Russia, with the pelvic fins and later pelvic girdle being a result of natural gene duplication of the forelimbs, but in a region further back in the body. So, whilst jawed vertebrates are descended from jawless ones, Cephalaspis was not one of them. So this evolution sequence is impossible, sadly. So yeah, the quote-unquote Silurian segment is kind of a mess scientifically. If it were to be remade today to be more accurate, there unfortunately isn't really a single geological formation with good representatives for all of the taxa featured in this segment for its story to remain mostly intact. There are a few that provide really close proxies for most of the taxa in this segment, but not all. Well, first and foremost, let's give it the correct title of Early Devonian rather than Silurian. The first candidate would be the Shetun Formation in South China. Its sediments preserve a coastal environment and is where Saurolepis hails from, as well as Zosterophyllum, an early vascular plant similar to Cooksonia, related to modern club mosses. As of 2023, a species of Pterigotus, P. wangi, was reported from there too. No true scorpions are known from here, unfortunately, so Brontoscorpio lacks a rep. Another candidate is the incredibly fun to say Beartooth Butte Formation in Wyoming. Its sediments similarly preserve an estuary environment, ideal for the migratory story. There are several jawless fish found here, some of which are even referred to Cephalaspis but likely represent other genera. Several scorpion genera are known from here. The genus Prearcturus is said to be the size of Brontoscorpio shown here, but its identity as a scorpion is also questioned, funnily enough, and may represent a crustacean. The Eurypterid Jacalopterus is known from here. Whilst this genus contains the largest known species of Eurypterid, J. renaniae, the species found here is the much smaller J. howelli, which may not be large enough to fulfill the role the Pterigotus has, preying on Brontoscorpio. There are also several early vascular plants known from here too. This provides a more accurate setting for this segment story, but still doesn't address the issue that jawless fish were not our closest ancestors at the time. I think the most parsimonious solution would be to move Saurolepis from China to Wyoming, as it's at least possible it could have travelled there across the Rheic Ocean and be incorporated into the story somehow. Later on in the show, the starting creature of the evolution sequences becomes different to the ending creature of the previous sequence. So maybe they could have done something similar here, have Hycoichthyes evolve into the jawless fish at the beginning, and then have Saurolepis be the starting creature for the sequence at the end. Cephalaspis is erroneously shown to evolve into a creature with jaws and 4 legs over 58 million years into the Devonian period, 360 million years ago, though I suppose you should really consider this segment the late Devonian. 360 million years ago is actually the exact same date as the Devonian segment in Sea Monsters, at almost the very end of the period. I'd say this is the most accurate segment in the show, and the one that's aged the best in 20 years. With that said, we again have a chronology issue, though this one is at least very minor. It is set in Pennsylvania, and based on fossil finds from the Catskill Formation. Whilst an accurate date for the 5th deadliest sea, the sediments of the Catskill Formation are slightly older, dated to roughly 365 million years ago, technically placing it before the 5th deadliest sea if you were to watch the entire Walking With series chronologically. By the late Devonian, many fragments of continental crust that will eventually form Asia detached from Gondwana and drifted north, forming the Paleotethys Ocean in their wake. The Rheic Ocean had narrowed considerably as Gondwana drifted northwards towards Euramerica. The Catskill sediments preserve a river delta in eastern Euramerica near the equator. These were deposited by the eroding ancient Acadian mountains, precursors to the modern Appalachians in eastern North America today, being washed downstream to the west into the Kaskaskia Sea, an inland sea covering much of central North America at the time. This segment was filmed in Devil's Postpile National Monument in California, at least the above water shots anyway. I'm not sure whether the underwater shots were filmed elsewhere. Living in this freshwater environment was Hynerpeton. Its name means creeping animal from Hyner, after Hyner, Pennsylvania, near to where it was discovered. It is only known from a single shoulder girdle, but its similarity to that of the more completely known Ichthyostega from late Devonian Greenland showed that it was also one of the first vertebrates to have limbs. They were descended from lobe-finned fish, whose strong muscular pectoral fins were efficient at not only lightly grasping and pushing off of objects in water, but also for supporting the animal for brief journeys out of water. Whilst the narration refers to Hynerpeton as an amphibian, I'd caution referring to it and similar animals as such. True amphibians of the class Amphibia didn't appear until the following Carboniferous period, and were not ancestral to us, but rather branched off from our ancestors and retained many of the traits of our shared fish ancestors. Instead, amphibian should be thought of more as a descriptor of its ecology rather than its phylogeny, as it was an amphibious, semi-aquatic tetrapodomorph, but that's a mouthful, and amphibian is a lot more comprehensive. As Hynerpton is only known from a single left shoulder girdle, I imagine much of this model was based on the more complete Ichthyostega, another more famous fisherpod as they've been nicknamed. I applaud the producers for going with a more obscure taxon for this famous moment in the evolution of life on Earth. Bonus points from me. The head looks basically spot on for Ichthyostega. The tail, however, looks closer to its contemporary Acanthostega, a more basal fisherpod thought to have been more aquatic with more fish-like fins on its tail, whereas Ichthyostega had a much more reduced tail fin. Perhaps they did this to make it seem more believable when we see the Hynerpton swimming, but it's impossible to say unless we learn what Hynerpton's tail looked like. The limbs of Ichthyostega are interesting as, unlike all modern tetrapods that have 5 digits per limb at most, it had 7 on its back feet, and Acanthostega had 8 on its hands. It's hard to tell, but I'm pretty sure they've given Hynerpton 7 fingers and toes. Since we don't know how many digits Hynerpton had, I can't really critique it, but based on Ichthyostega's hind limbs, it seems like a sensible assumption, as its hands have also never been found. It's still unknown why fisherpods had more than the standard 5 digits of today. Studies in 2011 and 2012 showed that Ichthyostega's hind limbs were too small to support its weight on land, and that its shoulders were incapable of the range of motion required for a sprawling gait seen in modern newts and salamanders, and more likely moved on land by dragging itself with its front limbs only, like mud skippers. Hynerpton's shoulder girdle had deep depressions on its surface, speculated to be attachment points for powerful muscles, suggesting it could support more weight than Ichthyostega. Whether it was capable of this salamander-like gait though, with all 4 limbs, is hard to say, but this wasn't known about at the time. It's also said to be 1.5 meters long, which is the length of Ichthyostega. Extrapolating from the size of the shoulder girdle, Hynerpton is estimated to be much smaller than this at around 70 centimeters. Once again, I love the coloration, which looks to be inspired by tiger salamanders. So overall, I'm kind of surprised they went with Hynerpton rather than the more completely known Ichthyostega, as this model might as well be that genus considering how much of its anatomy is inferred from it. It's just been moved to Pennsylvania. It was basically a perfect Ichthyostega for the time, but now maybe a bit dated. But it's meant to be Hynerpton, so it's good? We then get a very interesting deviation between the episodic and omnibus cuts, as the latter has more footage of live-acted scorpions, and explains how they've now become fully adapted to life on land, but their size is limited by both the less oxygen-rich air of the Devonian compared to water, and that their lungs are quote-unquote less efficient than those of vertebrates. This limitation has made them shrink and become an ideal food source for the first vertebrates to take to the land. As such, we then see one get eaten by Hynerpton. As far as I know, no scorpions are known yet from the Catskill Formation, but I'd be surprised if they were completely absent. It's a really impressive blending of CGI with reality too. In the episodic cut, however, the narration instead states that arthropod enemies still exist, but they've shrunk since their Brontoscorpio glory days, which is largely true, as by this time the huge predatory eurypterids like pterygotids had become extinct, thought to have been outcompeted by predatory fish, which became the apex predators by the late Devonian. The narration then states that in the last 50 million years, trees have evolved, and as there are no large herbivores on land yet to eat them, they have grown into massive forests with nothing to control their populations. Whilst they're portrayed by modern Californian pine and fir trees, these are likely meant to represent the genus Archaeopteris, one of the first trees, not to be confused with the similar sounding dinosaur Archaeopteryx. It was not related to any modern trees, as they are all spermatophytes, seed plants, which wouldn't evolve until the following Carboniferous period. Instead, Archaeopteryx could almost be seen as a transitional form between the ferns and seed plants, as it had a wooden trunk, but reproduced with spores like ferns. The plentiful plants have increased atmospheric oxygen, and we get an anatomical shot of Hynerpeton's lungs, which, if I didn't know any better, I'd say were actual lungs, as you even see them expand and relax again with each breath. It's thought that lungs first evolved from an enlarged sac in the esophagus of early bony fish. This highly vascularized structure allowed them to extract atmospheric oxygen by gulping air if living in oxygen-poor water. This trait can be seen in lobe-finned fish today in the appropriately named lungfish, as well as some basal ray-finned fish, such as B. shears. In more derived ray-finned fish, this organ became the swim bladders, sacs filled with air used to control buoyancy, but in our ancestors eventually separated from the esophagus into its own tract connected to the throat, the trachea. Evidence of this can be found in embryonic development of ray-finned fish and tetrapods, as both the lungs and swim bladders emerge from the developing gut. Low water oxygen content was a common occurrence in the Devonian, as the explosive success of land plants meant that when they died and fell into water, the huge influx of nutrients would fuel algal blooms, and the microscopic decomposers would use up huge quantities of dissolved oxygen in water to break them down. What the show doesn't mention, or touch upon at all really, is that the lack of population control of land plants caused an ice age due to them taking so much CO2 out of the atmosphere, which is an important greenhouse gas, causing temperatures to drop considerably. They're also suspected to be the cause of the extinction events in the late Devonian, and to have been interconnected with atmospheric oxygen levels throughout the following Carboniferous period, but I'll talk more about that later. We then get a close-up of the skin of a Hynerpeton puppet, showcasing how it's similar to modern amphibians. It has very thin skin for performing cutaneous respiration, performing gas exchange through the skin when wet like modern amphibians and some fish, reptiles and even mammals, suggesting it is an ancestral trait possessed by their common ancestor. It can dry out very quickly, however, meaning they can't be away from water for prolonged periods. Whilst this model only has thin skin, Hynerpeton and other fishopods like Ichthyostega may have retained some scales from their fish ancestors, but this is difficult to say for certain. We then see a male Hynerpeton take a dive in the river, or lake? It's variously referred to as both in the show. The narration states that the fish are now our ancestors' enemies. We're then reintroduced to another creature reappearing from sea monsters, the early cartilaginous fish Stephacanthus. And like the orthocone in the Silurian segment, it shouldn't really be here. While Stephacanthus was alive at the time, it isn't known from the Catskill Formation, and it's only ever been found in marine deposits, so depicting it in a freshwater environment is certainly a choice. There are some modern fish that can move between salt and freshwater, but it's impossible to tell if Stephacanthus had this ability, and it isn't supported by the fossil record. Whilst referred to as an ancient shark, true sharks of the group Selachii are not confidently known from the fossil record until the Jurassic. It was instead part of a more basal order of chondrichthyans, the Simoria A suitable replacement could be Tenocanthus, another predatory basal chondrichthyan that was actually known from the Catskill Formation. Funnily enough, it had independently evolved a very similar appearance to another chondrichthyan featured in another Walking With show, the Jurassic-aged Hybodus, seen in both Walking with Dinosaurs and Sea Monsters, so maybe retooling that model into a Tenocanthus would have worked better. I assume it's probably just meant as a stand-in for any Devonian chondrichthyan, as it doesn't get named and all it does is chase the Hynerpeton for a bit before being upstaged and eaten by the river's real apex predator, Hyneria. Like Hynerpeton, it is named after Hyner, Pennsylvania, and it was a large, freshwater, lobe-finned fish in the family Tristichopteridae. It's stated to be 5 meters long, but the real animal was closer to 3 meters, still being the largest carnivore in its ecosystem. Despite being slightly oversized, the model looks amazing. The scale detail is superb, and it just looks like a real fish. The striking red fins contrast wonderfully with the silvery striped body, and the glassy eyes look so realistic to me. When seen from above in this shot, you can even see how the torso connects to the head just like in modern fish. It's one of the best models, if not the best model in the show, and among the best in all of Walking With in my opinion. It just looks incredible and, well, real. What more could you ask for in a show aiming to bring extinct animals to life? I love this filming location too for the underwater scenes with all the sunken waterlogged vegetation, as this was extremely prevalent in the late Devonian. They would often just sink to the bottom and create labyrinths of branches and roots for aquatic animals to navigate. It's thought that this also prompted the evolution of vertebrate limbs, initially for grasping and manoeuvring through these cramped spaces and to escape predation from fish like Hyneria. I love this detail of the Hyneria's tail bumping this log in its wake. The male Hynerpton escapes to the shore where others have gathered to mate, but females will only choose the strongest and fittest males, and their mating season is very short. The narration states that Hynerpton are able to spend more time on land at night as they don't dry out as fast from the sun, which makes sense as many amphibians today are nocturnal. In the night, a rival male arrives and challenges our male to a push-up contest over territory. I know it sounds weird, but some lizards do this today, and considering Hynerpton may have only been able to move on land with its front legs, this may have been possible for them to do for intraspecific combat. Our male sees off the interloper, but the narration states he may be too late for love, and takes his frustration out on the camera by spitting on the lens because monsters. Interestingly, in the recap at the start of episode 2, this shot is seen during the day, so this is an example of day for night filming. The next morning, it appears all the female Hynerpton have left, but the male calls out across the lake anyway, and eventually a female arrives and the pair enter amplexus. Like in modern amphibians, the male mounts the female as she lays unfertilized eggs into the water, and the male fertilizes them externally. Because they're soft, they have to be laid in water, and young amphibians have gills, with some like axolotls even retaining them into their adult life stage. Whilst not known for certain, it's possible fishopods like Hynerpton were similar. I wonder if they used actual frog spawn for this, or if these are props. The Hynerpton pair then narrowly avoid an ambush attempt from a Hyneria, attacking similar to some modern killer whales chasing sea lions onto beaches. The fish then uses her powerful lobed pectoral fins to drag herself up the shore and grabs the male Hynerpton by the tail and slides back into the water. I don't know if they were capable of dragging themselves over land quite like this, but it's so cool. This scene also acts as an allegory for how both the fishopods, and by extension actual amphibians, would always be at risk from aquatic predators with their dependency on water. The narration states that the amphibians are about to find a way to leave the dangers of the water behind for good, and the wording is again a bit confusing as, like I said earlier, true amphibians hadn't evolved yet and are not ancestral to us. The Devonian segment and episode 1 ends with a very unique evolution sequence of a Hynerpton egg evolving over 60 million years into an egg with a tough protective shell. So overall, the Devonian, or I guess the late Devonian segment, was probably my favourite so far. The models look great, and accuracy-wise, it was great for the time and has aged pretty well all things considered, as even things like calling Hynerpton an amphibian is likely just for ease of watching, and Stethecanthus being in a river is odd, but only a minor issue. This one also has the best story so far, I feel, possibly owing to animals becoming more complex and relatable over time. Episode 2 has a montage intro sequence summarising the first episode and teases what is to come in this one. The eggs are seen hatching, and just as they're about to be attacked by an arthropod, it cuts to the title sequence for episode 2. This scene was shown at the end of episode 1 and similarly gets cut off by the credits, whereas the omnibus version actually shows the arthropod attacking the nest. A close-up shot of practical fangs tipped with blood then fades to black. It's so interesting to me just how how different these two versions can be at times. The first segment of episode 2, but 4th in the show overall, is set in the 5th period of the Paleozoic, the Carboniferous, 300 million years ago. Strap yourselves in because boy do I have a lot to say about this one. It is set in Kansas and somewhat based on fossil finds from the Stanton Formation. Would you believe this gives us yet another chronology issue, as the sediments of the Stanton Formation are dated from 306 to 304 million years ago, which would only be a very minor grievance like the last segment if it weren't for a significant event occurring late in the period, but we'll talk about that later. The Carboniferous was a period of immense tectonic movement and uplift, and 300 million years ago was right at the end of the period, so there's going to be a lot of rapid-fire geography summarising. In the early Carboniferous, Gondwana had drifted north, and what is today northern South America and northwestern Africa collided with Euramerica, completely closing the Rheic Ocean and creating the ultimate supercontinent, Pangaea. This collision pushed up the Appalachian Mountains in eastern North America, the Anti-Atlas Mountains in what is now Morocco, and many massifs in what is now Central Europe. These collectively formed the Central Pangaean Mountains. Many of the crustal fragments that form Asia and Eastern Europe today had continued to drift north and westwards into the Northern Hemisphere. The Kazakhstan block collided with the Siberian Craton, pushing up the Altai Mountains in what is today Central and Eastern Asia. By the late Carboniferous, Pangaea had also drifted north, causing the Kazakhstania plus Siberia landmass to become accreted to it, pushing up the Ural Mountains at their plate margins in what is now Russia and Kazakhstan. The sediments of the Stanton Formation in Kansas preserve a heavily forested river valley close to the equator, nearby to the Pennsylvanian Epicontinental Sea, which covered much of what is today Western North America. This segment was filmed in Jonathan Dickinson State Park in Florida, with some additional Carboniferous plants added with CGI, and I think it's probably the best analogue for the coal swamps of the Carboniferous that you could find in the modern day. The on-screen stats state that the oxygen content of the time was 40% higher than today, and this is fairly accurate, as estimates for atmospheric oxygen levels in the Carboniferous based on isotopes found in rocks dated to this time give percentages as high as 35% of the atmosphere being composed of oxygen, compared to the 20 to 21% of today, though most estimates are more conservative at around 25% and rarely exceeding 30%. As was mentioned in the previous segment, this atmospheric oxygen resulted from the explosion of photosynthesizing land plants. In the hot and humid tropics of the Carboniferous, plants flourished around the waterways, forming vast swamp forests. The dominant plants by far were the bizarre Lepidodendrales. The narration describes them as distant relatives of ferns, which is a very broad and vague description. They were lycophytes, the most basal group of land plants still alive today, which includes the modern club mosses and quillworts. Like their modern relatives, they reproduced with spores rather than seeds. They were not ancestors of them, but rather a completely separate order that left no descendants. Like modern trees, they possessed lignin for structural support, allowing them to grow woody trunks with bark. I believe these are CGI in this shot, but occasionally live acted by modern bald cypress, owing to the Florida filming location, which have independently evolved to fill a very similar niche as the arborescent lycophytes as they're known as. When young, they had no branches and their leaves would actually grow out of the bark. When they aged and the leaves died and fell off, they would leave scale-like marks in the bark, granting them the colloquial name of scale trees. As they grew, the ends of their branches would resemble the plant in a younger growth stage, and you can see this in some shots of the canopy, which is a fantastic detail. Owing to their place near the base of the land plant family tree, they produced far less lignin than modern trees, and so were not as structurally sound. They're also thought to have grown quite rapidly, and only produce spores once in their lifetime before dying. It's also thought that lignin decomposers either had yet to evolve or were not as prevalent as today. This all may have contributed to the plentiful fossils we have of these plants across the globe, as they collapsed and died so frequently. It's these plants that give the Carboniferous its name, as it means carbon-rich, after the plentiful fossils of scale trees that died en masse without decomposing and became compressed and heated within the earth, becoming coal. It's also likely the scale trees' lack of decomposition caused them to sequester a lot of carbon during the Carboniferous, meaning there was less available carbon in the atmosphere to form carbon dioxide. Oxygen levels and temperatures rose and fell many times throughout the period. When plant populations and therefore oxygen were high, CO2 and therefore global temperatures were low and polar ice sheets grew. This would also lower sea levels and cause the plentiful tropical swamps and forests to die out and be replaced by more arid environments. As the plant population and oxygen levels lowered, CO2 levels and global temperatures increased, melting glaciers and raising sea levels again and bringing moisture from the ocean back to dried out areas. This cycle continued from the late Devonian 360 million years ago, all through the Carboniferous, and didn't end until the start of the late Permian period around 260 million years ago, a total of roughly 100 million years. Below the canopy, you also see plentiful ferns, which would remain successful up to the present. You can occasionally spot some other very modern looking Floridian plants in the background like palms, but you really have to be looking out for them to notice. Whew, that was a lot of earth science preamble. Now let's talk about the animals. This segment actually has the most animated creatures in the show, with 5. The shelled eggs we saw earlier are called amniotic eggs. They have several membranes, one of which gives them their name, the amnion. These surround the developing embryo and are contained within a strong but porous shell, meaning they can be laid on land, and the embryo can perform gas exchange through the shell and be born as air breathers, foregoing metamorphosis from an aquatic larval stage. These animals are known as amniotes, and they include reptiles, birds, and mammals, though some have secondarily foregone the eggshell entirely and instead give birth to live young. I'm not sure whether early amniotes would have laid hard or soft-shelled eggs, as no fossil eggshells are known from this time, and eggshell rigidity varies a lot in modern amniotes, so I won't critique the hard shells seen here. The animals seen hatching are Petrolacosaurus, referred to as the first reptiles. Its name means rock lake lizard, referring to the environment its fossils were preserved in. Despite having lizard in its name and looking a lot like one, true lizards in the order Squamata didn't appear until the Mesozoic era. Rather, lizards have convergently evolved a very similar appearance to these very early reptiles. Speaking of lizards, we see a close-up of Petrolacosaurus' skin. Whilst the narration is correct when saying that the tough, scaly skin prevents moisture from escaping the body, preventing it from drying out like in amphibian-grade animals, the close-up shows overlapping scales. These are only known in lizards and snakes, and the non-overlapping scutes of crocodilians and turtles formed in a deeper layer of the skin that attach to the muscles are thought to represent the ancestral condition for reptile skin. So it doesn't seem reasonable to me to reconstruct an early reptile like Petrolacosaurus with the unique derived overlapping scales of snakes and lizards. It also has a line of feature scales down the midline of its back, like some modern lizards do. I don't know if Petrolacosaurus would have had these, but they look cool at least. They've given it slit pupils, which are seen in some modern reptiles. Vertical slits are useful for predators that hunt in varying light conditions, like cats or crocodilians, whose line of sight is close to a horizontal surface. Seeing as Petrolacosaurus was a fairly small insectivore at only 40 centimeters long, it was very close to the ground, and the considerable shade provided by the swamp forest canopy at times may have made slit pupils a plausible adaptation. However, many modern insectivorous lizards live in forests and have round pupils, so who knows. Otherwise though, I think the CGI model is essentially perfect. All the proportions look spot on to the known fossils, with unique extra long fourth digit on the back feet that would shrink in size in most later reptiles. Even the teeth look perfect, as the frontmost ones in the top jaw are the largest, and precursors of canines are seen further back in the jaw. I love the green coloration with white stripes and the red rings around the eyes. I'm not sure if this was based on a modern animal, but it looks great. With all this in mind, a paper published in 2022 found it and other basal reptiles in the group Araeosolidia to actually be stem amniotes rather than reptiles. I don't know how well supported this hypothesis is by other workers, and it was known as an early reptile at the time of production, so I'd say this portrayal is fine as of now. What isn't fine about it, we'll talk about later. As for the arthropod seen attacking the nest, this animal is referred to as a mesothelae spider, or just mesothelae. As far as I can tell, the story goes that this creature was based on the genus Megarachne. When it was first described in 1980, with a length of roughly 54 centimeters, it was thought to be the largest spider ever found, hence the name meaning great spider. Despite spider experts being skeptical of this referral, the giant spider image quickly became popular with people, and is likely why the producers wanted to include it in the show. It wasn't until 2005, when the show was well into production, a second, more complete specimen was found of Megarachne, showing that the spider-like features were a result of parts of the body being missing in the first specimen. The second specimen revealed that Megarachne was in fact a eurypterid, a sea scorpion, though it didn't live in the sea, but rather fresh water, using their frontal appendages to sweep through sediment to catch small invertebrate prey, rather than having huge fangs and hunting down tetrapods like is seen here. The complete guide does actually address this on the Pterygotus page. Megarachne also didn't live alongside the other creatures seen in this segment, as it's only known from the Bajo de Veliz formation in Argentina. The oldest known fossil spiders are found in Carboniferous rocks, but none are known that are of similar size to this creature. This animal is shown to make web bunkers in holes like modern mesothelae spiders, but doesn't make silk-hinged trapdoors, interestingly. Instead making web trip lines and sensing for vibrations, which some other spiders do today. It's an oddly good, large, generic mesothelae spider, as it has their signature trait of their spinneret organs being on the underside of their abdomen, rather than at the very back of it like other spiders. The cephalothorax, that is, the combined head and torso section, is mostly black or dark grey, but with a striking red abdomen and chelicerae. The legs on both the CGI model and puppet also have subtle hair-like setae on them like modern spiders, which is a nice touch. So yeah, this is now an extremely outdated reconstruction, but there was nothing that could be done so late into production. We see a female mesothelae returning to her web-covered burrow, waiting to ambush potential prey. A Petrolacosaurus wanders close to the entrance, and the spider pounces after it and gives chase. The reptile manages to outrun the spider and reach a hollowed-out scale tree trunk to hide in, which I assume was a prop made for the show, and it looks really convincing. Fossils of the Carboniferous reptile Hylonomus have actually been found preserved within the hollowed-out trunks of these trees, so this is actually kind of supported by the fossil record, weirdly enough, which is cool. We then get an anatomical shot of Petrolacosaurus's heart, with the narration stating it is much more efficient than his enemies, which again, the wording hints at them being superior when they're not. Arthropod hearts are a long, tube-like structure that stretches the length of their body. Their blood essentially bathes all of their internal organs, and they extract oxygen from their surroundings directly into the blood, and therefore the organs. When the blood becomes deoxygenated, it passes through tubes to the heart, which then pumps it back out to become oxygenated again. The vertebrate heart, however, is protected by the rib bones in the chest area, is mostly round, strongly muscular, and actively pumps blood through dedicated blood vessels all around the body. I believe the new adaptation this segment is trying to highlight, without actually saying it, is that true tetrapods evolved a 3-chambered heart, permitting a double circulatory system, with one route that pumps blood exclusively to the lungs and another for the rest of the body. Amphibians and many reptiles retained the 3-chambered heart with 2 atriums and 1 ventricle, meaning oxygenated blood is pumped from the heart separately to the lungs and the rest of the body through the arteries, but when deoxygenated, returns through the veins into the same vesicle in the heart to be pumped out again. Some amniotes would later evolve a 4-chambered heart, where the lungs and the rest of the body each have their own atria and vesicle chambers in the heart, The spider eventually catches up, and whilst at first she can't seem to fit into the log's entrance, she finds another hole and lands on the reptile, stabbing and killing it quite violently with its fangs, whilst the helpless reptile makes goat noises, which are used a lot for these scenarios in extinct nature documentaries. This is followed by a small, short scene exclusive to the omnibus cut detailing how the abundance of plants in the Carboniferous has allowed arthropods to grow so large, which is neat. This theory has been challenged recently, as studies have found that oxygen levels don't affect insect size that much, and that the more likely reason they became so large was due to lack of competition, and disappeared due to being outcompeted by amniotes. I think it's also worth clarifying that most Carboniferous bugs were, well, bug-sized, but they're rarely shown because they're not as exciting. The giants were exceptional forms rather than the norm. The spider then drags the reptile back to her lair to inject him with digestive juices, but she finds her burrow has become flooded by rising water levels. The narration states that she can't dig, and so will have to find another hole she can adapt with her webbing. But many modern trapdoor spiders are capable of digging their own burrows. I assume they gave it this limitation so as to provide a sort of central character for this segment of a spider searching for a new home, which leads her to bump into the many other inhabitants of the swamp. It works, but I feel like a more believable story would be that she just needed to find higher and drier ground to build a new burrow, as that way we could still have her encounter all the other creatures without making them unable to dig. This is especially odd as we later see a bunch of mesothelial burrows in close proximity, so I guess there just happened to be a bunch of random pits in this little area. I don't know, it's a little weird, but this portrayal of this animal is completely wrong now anyway, so I guess it doesn't even matter. As she drags her Petrolacosaurus meal with her in search of an estate agent, it gets stolen by a huge flying insect, and Framestore somehow managed to make an animated extinct spider emotive and even comedic with what I could almost describe as a stupefied expression as she looks up to the sky after her food just got yoinked from her fangs. How did it even do that? The thief is a Meganeura. Its name means big vein, and whilst the narration calls it a monster dragonfly, the oldest fossils of true dragonflies of the group Anisoptera don't appear until the early Jurassic, and it's unclear when their ancestor first evolved. Meganeura was a Meganisopteran, colloquially known as griffin flies, an extinct group closely related to dragonflies in the group Odonatoptera. Like their modern relatives, they were fast predators with 2 pairs of wings as adults. It's still unclear both when insects first evolved and when they first evolved flight, but what is known is that they were the first group of animals to be capable of flight, and that this was pivotal to their success that continues to this day. With a total wingspan of 65 centimeters, Meganeura is often referred to as the largest flying insect to ever live, but this title is actually held by its close relative Meganeuropsis from the early Permian with a wingspan of 71 centimeters. The model looks really good. It has the characteristic giant compound eyes of modern dragonflies, the 2 pairs of wings which are also correctly veinated and correctly lack the pterostigmata, a heavier section on the leading edge of some insect wings that help to avoid flutter whilst gliding. The elongated abdomen is present and the cerci on the end are consistent with those of modern female dragonflies. The only issue I can make out is that it's lacking spikes on the legs, thought to have been used to grab and skewer prey whilst on the wing, like on modern dragonflies. It's a shame these are missing, as it's otherwise a fantastic model with a really striking and naturalistic coloration, with red eyes, a yellow body with black and blue mottled patterns. Whilst Meganeura fossils are dated to this time, it's only known from France. Ironically, Meganeuropsis is known from Kansas, but only from early Permian sediments. No griffin flies are actually known from this exact time in North America, but it could be that thanks to the interconnectedness of Pangaea, that Meganeura's range could have also extended to North America. There were also other griffinfly genera known from North America, such as Carpenter typus and Orlatupus, but these were considerably smaller and from older sediments. Something else to note is that Meganeura was apparently adapted to more open habitats rather than dense swamp forests, so this was likely not an appropriate habitat for it. Something interesting I only discovered whilst researching for this part was that in this Meganeura promo image you can see another unidentified flying insect, a UFI, if you will. I wouldn't be surprised if these were meant to be Paleodictyopteroids, a completely extinct group of early insects that also reached large sizes, had extremely long cerci, and had mouthparts likely adapted for piercing and sucking out plant tissues, similar to modern true bugs. They represent the oldest known winged insects and herbivorous insects. Again though, I have no idea if these are meant to be those, as they're never seen in the show, nor are they mentioned anywhere. The narration states that high above her Carboniferous kingdom, normally she's... As the Meganora feeds on her stolen kill in the canopy, we see that the reason the water levels have risen is due to an approaching storm. The narration also foreshadows that lightning strikes can trigger explosions, leading to extremely fast spreading wildfires due to the abundance of oxygen in the atmosphere. Down below, we're introduced to some Carboniferous amphibians, another example of monsters being vague and not naming animals by genus. According to the complete guide, this model is based on Proterogyrinus. Its name means earlier tadpole, and it's also another example of monsters labelling something as an amphibian when it only refers to its lifestyle, as it was not a member of Amphibia but of Embolomerae, a group of tetrapods more closely related to amniotes than to amphibians, sometimes referred to as reptiliomorphs. Despite this, they're thought to have reproduced in water like true amphibians. The model is quite good, but the head looks a bit shrink-wrapped. It does at least match the skull very closely. The torso and limbs look perfect, but the tail looks very round in cross-section, when its tail vertebrae were tall and likely supported a newt-like paddle. The narration states that their skin restricts them to the water's edge, and it's thought that early tetrapods like Proterogyrinus would likely have had amphibian-like skin. The coloration is naturalistic, but not the most interesting, with a dark grey body and white stripes. Proterogyrinus is known from West Virginia, from rocks dated to 326 to 323 million years ago, so would have likely been extinct by this time and didn't live in Kansas. So overall, it shouldn't be here, and the model is good but not quite perfect. I love this shot of the mesothelae in the background, one of them lifting its head to roar, and when it lowers the mesothelae is already walking in the other direction. That's a nice touch. Having been scared away from the shore, the mesothelae wanders past several of her own kind, not wanting to share their web bunkers. Avoiding them, the spider crosses paths with Arthropleura. Its name means jointed ribs, and it was the largest known terrestrial arthropod, capable of reaching lengths of 2 meters, if not more. The narration describes it as a distant relative of modern millipedes, which at the time was kind of correct, as it was classified as a myriapod, the arthropod group including millipedes, centipedes, and their more obscure relatives. Arthropleura was actually included within the millipedes in the class Diplopoda, but within its own order, Arthropleurida, separate from all living millipedes. However, a 2024 paper describing some amazingly preserved juvenile Arthropleura specimens revealed a lot about this animal that we'd previously only been able to guess, particularly the head. Whilst the narration states that it is a vegetarian, like modern millipedes, it was thought to have fed on detritus, be it decayed plants or animals. This model has very large mandibles, but the 2024 paper describes how the juvenile specimens had much smaller mandibles than those seen here. Something totally unexpected were its eyes. Whilst the modelers made a sensible decision to base the eyes on modern millipedes, which have very simple eyes, these specimens showed that Arthropleura had large, stalked eyes similar to some crabs that stuck out from the sides of its head. This same paper also classified Arthropleura as more basal than the centipede-millipede split, and suggests that Arthropleura was semi-aquatic. Many trackways of the ichnogenus Diplycnites, which consist of widely spaced, blunt tracks dated to this time, are attributed to Arthropleura. These are often found in sediments preserving coastline environments both above and below the waterline, suggesting this animal lived along the shores of lakes or the sea and ventured into shallow water. This is supported by its unique crab-like eyes, which may have been useful for looking out for potential predators swimming above it. In 2019, another paper found that despite often being found in deposits rich with plant fossils, Arthropleura was most prevalent where forests weren't, and likely lived in more open habitat rather than forests based on their tracks and burrows being found in open coastal delta environments across Europe and North America. Diplacnites tracks are known from this time from Kansas. Whether Arthropleura lived alongside Petrolacosaurus though is unclear. The armor segments and the legs though still look perfect based on the fossils. So yeah, this model is quite the time capsule now, as our knowledge of Arthropleura has grown a lot since 2005. Whilst it's now heavily outdated, for the time this was about as accurate of a reconstruction of this animal as you could make, seeing as we didn't have the head. I also really love the red coloration, with hints of blue and yellow. The Arthropleura rears up at the Mesothelae, who chooses to let the giant pass. This animal is often portrayed as rearing, and it's become somewhat of a trope or paleoart meme, when it's not even certain it could do this. Modern millipedes are able to rear up to climb, but whether the enormous Arthropleura could support its greater mass like this, I'm not sure, but it does look cool. As he leaves his dead tree burrow to feed, he then stumbles into a Proterogerynus, who's very upset at him trespassing on its new property. It rears up to intimidate it, but this doesn't deter it. I noticed a small animation/editing error here where the Arthropleura fades out of existence slightly before the tree passes in front of it in this sweeping shot. The Arthropleura then lowers and the Proterogerynus bites at its tough armor to no avail. The Proterogerynus then flips and impales the Arthropleura on a sharp tree knee. I don't know if any Carboniferous plants would have had these strange knee structures some modern swamp plants produce, but it certainly makes for a really cool scene. Maybe they're young scale trees. I like that they correctly portray arthropod hemolymph as yellow, as the skewered animal morbidly slides down the bark, writhing and transitioning to a puppet. I wonder what this substance actually was when they filmed it. This would also be the second time Monsters has shown an arthropod's armor getting split. The Proterogerynus now has a feast. The storm moves closer and the Mesothelae at last finds a new hole. A Petrolacosaurus sprints away, with the narration foreshadowing that their speed and stamina allow them to escape danger. She turns it into a new silk-lined burrow, but that night, the storm seen earlier arrives and has ignited wildfires. Meganeura are forced down below the canopy, and Proterogerynus leap from the water trying to snap them up. This was done by having crew members wrapped in black bin bags and jumping up out of the water, and Chloe Leland recounts the strange experience of directing and filming this sequence in the behind the scenes, as tourists would occasionally go past them in canoes and see the bizarre sight of a woman yelling at people dressed completely in black to jump faster and higher in swampy water. The potential embarrassment was worth it though, if you ask me, as the interaction between the water and the CGI looks fantastic. Whilst the spider hides in her burrow, lightning strikes and the screen fades to black. We then see the devastation caused by the resulting wildfire to the area, with burnt wood everywhere. Petrolacosaurus was able to outrun the flames, and despite seeming like it has a death wish by walking into the Mesothelae's burrow, he pulls out the charred corpse of the giant spider, having been struck by lightning. The narration puts it best when it says, "The reptile gets a spider barbecue." It's a really fitting way to end off this story, as it began with Mesothelae hunting Petrolacosaurus, but now the roles are reversed. Walking with Dinosaurs has a very similar narrative in the episode Cruel Sea, with the Lipleurodon and Eustreptospondylus. This also symbolises the Carboniferous and the following Permian period as a whole, with amniotes gradually coming to take over the land from the giant arthropods. The narration makes 3 closing statements one after another, and each warrants some clarification. The first is, the era of the giant bugs is coming to an end, which if referring to the Carboniferous period would be correct, but not if it's meant more literally. This is followed by, the climate is drying and the atmosphere is losing oxygen, which is also correct, but this had been the case for millions of years already. 300 million years ago would be after the Carboniferous rainforest collapse, a minor extinction event where the giant lycopsid trees became extinct in Europe and North America, and were mostly replaced by tree ferns and seed plants around 305 million years ago. The swamp forest became restricted as Pangaea continued to come together, and gradually became more arid at the continental interior, as seaways closed and the nearest coastlines and the moisture they provided to the land became more distant. However, when it then says the monster insects and spiders can't survive the change, it's difficult to discern if they mean the drop in oxygen makes it so they can't maintain their giant sizes anymore, they're not as well adapted to more arid environments, they're being outcompeted by vertebrates, or maybe some combination of the above. However, some of the enormous arthropods like Arthroplura and griffinflies survived into the following early Permian. If anything, insects got larger as the oxygen content dropped, as the two largest griffinflies, Meganeura and Meganeuropsis, are both dated to after the rainforest collapse. So yeah, by 300 million years ago, the scale tree dominated swamps of Europe and North America would have already been gone, replaced by tree ferns and early seed plants. What is still thought to be the case that the show portrays is that with their tough skin, speed, stamina, and eggs that can be laid away from water, amniotes were well equipped for a drier climate. The Carboniferous segment ends with Petrolacosaurus evolving into a much larger amniote, specifically a synapsid. Similar to the Silurian segment's ending, we have another big issue as Petrolacosaurus was not ancestral to synapsids. Amniotes can be divided into two groups, the sauropsids, which is basically equivalent to reptiles, which by definition includes birds, and synapsids, which include mammals and are non-mammalian relatives. These can be told apart by their skulls. Reptiles had 2 holes in the skull in addition to the orbit, whereas synapsids had only 1. Some later reptiles would secondarily lose 1 or more of these holes, the latter being known as anapsids. Keep that in mind for later. The 2022 paper reassigning it notwithstanding, Petrolacosaurus had 2 skull openings, making it a sauropsid, meaning it was not ancestral to us or to any synapsid. The early synapsid genus, Caenomagnathus, is also known from the Stanton Formation and was a contemporary of Petrolacosaurus, though at the time it was considered a species of the genus Haptodus, H. garnetensis, until being split off as its own genus in 2020. Okay, so overall, the Carboniferous segment has aged very poorly scientifically, but that can't be helped, as there's no way of knowing how much future studies can change what we used to think, like Megarachne turning out not to be a giant spider, and Arthroplura turning out to be a millipede trying to be a crab. We can, however, critique the liberties taken based on what was known at the time, as this segment is plagued by geographical and chronological issues. Seeing as Pangaea was in place at the time, I can forgive the geographical issues, as it's at least feasible that all of these animals from other parts of the world could have reached Kansas. Setting it so late in the Carboniferous period, and crucially after the rainforest collapse though, means that the iconic scale tree swamps of this period were already gone mostly by 300 million years ago, and indeed the sediments of the Stanton Formation, dated to during and shortly after the collapse, preserves a coastal forest where Petrolacosaurus would have lived, dominated by conifers, not scale trees. If this segment were to be remade today to be more accurate, it's in a similar boat to the Silurian segment in that there's no single geological formation that has good representatives for all the creatures seen. I think the best approach to take would be to instead base it on findings from the Joggins Formation in Nova Scotia, Canada, and set it 317 million years ago. This would be before the rainforest collapse, and indeed it preserves a coastal coal swamp dominated by scale trees near the shores of the Pennsylvanian epicontinental sea. The basalmost and oldest known synapsid is known from here, Acerfestera, but until 2020 it was thought to have been a more basal tetrapod of varying affinities since it was first named in 1934. This would be a more appropriate replacement for Petrolacosaurus, as it was likely our closest ancestor at this time. The early reptile Hylonomus is also known from here, so could be used as an interesting parallel to show how similar the ancestors of modern reptiles and mammals started out, and how different they are now. Baphites is known from here, and it was was an embolomere and very similar to Proterochorinus. Diplacnites tracks are well recorded from the Joggins Formation too, so Arthroplura was likely present there as well. Indeterminate griffinfly fossils are known from Nova Scotia, but from sediments younger than the Joggins Formation. I'm also doubtful they'd be as large as Meganeura, and it's possible that the rainforest collapse was what allowed them to become much larger, so not sure how you'd adapt that. That just leaves the giant spider. Probably the easiest solution would be to just replace its predatory role with that of a scorpion, perhaps Eoscorpius, where some estimates put some species as reaching over 30 centimeters long, and is similarly known from Nova Scotia but from sediments younger than the Joggins Formation. That could also run into the potential issue of the show becoming too scorpion heavy, with it being the third segment in a row to feature them. Despite it being all over the place scientifically, I think the storytelling and narrative is really well done, and it might even be my personal favourite segment of the show, that or a very close second. Petrolacosaurus is erroneously shown evolving into a synapsid over 20 million years into the sixth and final period of the Paleozoic, the early Permian period, 280 million years ago. Rejoice everyone, for this is the first segment in the show to have no anachronisms. Or does it? It is set in Bromacher, Germany, and presumably based on fossil finds from the Tambach Formation, though again, put a pin in that for now. The oxygen content stat has now been replaced with global temperature, and it claims it's 20% colder than today, but calculating climate and global temperatures for past time periods is extremely difficult, and different methods can produce different results, so take these with a pinch of salt. The extreme seasons listed as hazards is correct. Annoyingly though, the show doesn't explain how or why these lower temperatures or extreme seasons occur. I only know, because of doing my own research, that this is due to the formation of Pangaea and the Ice Age's glacial cycles. Being surrounded by essentially one giant ocean, Pangaea massively altered ocean currents, causing mega monsoons, which would both intensify seasons and rob the continental interior of moisture, causing deserts to spread. In the early Permian, the world was quite similar to how it was at the end of the Carboniferous, as Pangaea had continued to drift north. To its east, another crustal fragment called Cimmeria, that would later form part of Asia, broke off from Gondwana and began drifting north towards the North and South China blocks, which are now collectively referred to as the microcontinent Cathasia. This region in the tropics would actually act as a refugium for the scale trees that dominated the Carboniferous and persisted until the end of the Permian, whilst the rest of the world was being taken over by seed plants like conifers, better adapted to the dry climate and strong seasons, with their tough and resilient seeds that can lie dormant for long periods of time until favourable conditions arrive. The Tambach Formation represents an inland mountainous environment, part of the central Pangaean Mountains, with a highly seasonal climate, similar to modern tropical savanna. This segment was filmed in the ancient bristlecone pine forest area of Inyo National Forest in California, and it's a very fitting environment for the Tambach Formation. This place is famous for housing the oldest known living tree, Methuselah, a Great Basin bristlecone pine, over 4,800 years old. Whilst these early Permian trees are of course far older, and the pine family didn't appear until the Cretaceous period, they fit the role of generic early conifers adapted to harsh weather and poor soil. Perhaps these are meant to be the genus Walschia, known from the Tambach Formation. Whilst the environment is an excellent representation of the Tambach Formation, the animals are not. Well, sort of. The animal Petrolacosaurus was incorrectly shown evolving into is Edaphosaurus. Its name means pavement lizard. The second half of its name is perhaps misleading, as it was not a reptile but a synapsid. The narration refers to them as mammal-like reptiles, which was a common name for non-mammalian synapsids at the time. This is a misleading name though, and if anything, reptile-like mammals would actually be closer, but the preferred term now for these animals is stem mammals. Walking with Dinosaurs also had this issue when referring to the cynodont in the episode New Blood. when synapsids were not reptiles at all. In the 1990s and 2000s, these terms were still being properly defined, so I suppose it could be forgiven. Bottom line, despite what these shows say, synapsids are not reptiles, nor are they descended from reptiles. Back to Edaphosaurus, there are a few species known, and I'm pretty confident this model represents the type species, E. pogonius, based on the shape of its sail. It was also the largest species, at 3.5 meters long, and in fact the largest member of its family, Edaphosauridae. Whilst it did live 280 million years ago, Edaphosaurus's presence in Europe is dubious, and is only definitively known from North America, with E. pogonius specifically hailing from the Arroyo Formation in Texas. There were also Carboniferous species of Edaphosaurus, but these were not E. pogonius. Just to mix up the pot even further, Petrolacosaurus actually lived alongside a more basal Carboniferous Edaphosaurid, Ianthosaurus, whom Edaphosaurus may not have been a direct descendant of, but evolved from the same ancestors. The function of the neural spines and the sail they supported in Edaphosaurus, and in fact many animals with sail structures, has been debated, essentially since it was first described in 1882. Here we see a herd in autumn using their sails for thermoregulation, with an anatomical shot of the sail's thin skin membrane. By pumping blood into the sail and turning it parallel to the sun, it can absorb heat to warm up and turn it perpendicular to the sun to radiate heat off to cool down. Most workers nowadays consider display and species recognition to be the main function of the sail, as related animals had considerably smaller sails that would have been poor for thermoregulation. With this in mind, the assertion made by the narration that mammals have inherited this thermoregulatory ability doesn't really make much sense. The huge sails are thought to have gradually grown over generations, with individuals with larger sails likely being sexually selected for, as they telegraph the animal's fitness. The spines are correctly reconstructed, with the unique horizontal, bony crossbars jutting out. The head looks perfect based on the skull, including the gigachat chin. The leg posture and gait of Edaphosaurus and related animals is the matter of some debate, but most workers find a semi-sprawled posture to be the most likely, similar to the high walk crocodilians will sometimes do, which this model portrays, which is really good. Whilst many early reconstructions in the late 19th and early 20th centuries gave Edaphosaurus and related animals a short tail, this was due to the tails being incomplete. More complete specimens showed that these animals had longer lizard-like tails, and this model's tail length looks spot on. How much the tail was held off the ground in these animals is still unclear, so I won't critique this. They have a cool colour scheme, with a dark grey body with yellow stripes and a blue and yellow sail with a grid-like pattern, which is cool. Something else cool is that they're translucent, which is an awesome detail to add. Overall though, this portrayal is a bit dated now, but anatomically, this is a wonderful model of Edaphosaurus pogonius. It just isn't known confidently from Germany. The narration states that reptiles have now spread across the globe, which, if it actually means synapsids, wasn't quite the case yet based on the fossil record. This doesn't seem to have occurred until the middle Permian, but it could simply be that we haven't yet found early Permian synapsids outside of Euramerica just yet, or if there are any synapsid fossils of that age there at all. The narration also states that conifers are newly evolved, even though they evolved in the late Carboniferous, but they didn't become as prevalent until the Permian, so it can slide with that context. There is then a scene exclusive to the omnibus cut of a young Edaphosaurus and presumably its mother being harassed by what looks like a dragonfly that reuses the Meganeura model. The griffinfly genus Meganeuropsis is known from the early Permian Wellington Formation in Oklahoma, nearby to Texas, but it's unclear whether this genus was still around by 280 million years ago. No dragonfly relatives are known from this exact time for North America or Germany, so it's anybody's guess really. Several griffinfly genera are known from the Salagou Formation in France dated to this time, nearby to Germany, so maybe it could be one of those. It's also entirely possible that griffinflies were still present in the area, we just haven't found them. The narration states that insects have shrunk since the Carboniferous, which is true by this specific point in the Permian, but like we said earlier, the giant griffinflies persisted into the early Permian in general with Meganeuropsis. Stalking the herd, we get a cool shot of another sailback, lurking behind a slope before fully revealing itself. Dimetrodon. Its name means two measures of tooth, and we'll see why a bit later. It was a member of another early synaptid family, the Sphenacodontidae. Dimetrodon is only represented in Germany by the smallest species, D. teutonis, whereas this model is clearly based on one of the larger North American species. Based on the shape of the sail and the fact it was contemporary with Adaphosaurus begonius, I'm pretty confident this is meant to be Dimetrodon grandis, the second largest species at roughly 3.5 meters long, and its sail standing 2 meters tall. Speaking of the sail, the skin membrane is no longer thought to have extended to the tips of the neural spines, at least in some Dimetrodon species. This is based on specimens of D. giganhomogenes, where the spines showed signs of breaking and then healing. Whilst the middle portions of the spines healed relatively straight, the tips healed in all sorts of weird directions. This indicated that the lower portions of the spines were being supported by a strong skin membrane, acting like splints whilst they healed, whereas the tips were not, indicating the sail did not extend to the tips of the spines. Whether this was the case in all Dimetrodon species, though, is unclear. Something else interesting is that sails are thought to have evolved independently in Sphenacodontids and Adaphosaurids via parallel evolution. The leg posture and gait may be too sprawled by modern standards based on the ichnogenus Dimetropus, thought to represent tracks made by Dimetrodon, which is really weird since the Adaphosaurus's posture looks perfect. In a paper published in 2025, the skin is now known to have had scales on its underside based on the ichnogenus Bromacharicnus, thought to be a body impression made by Dimetrodon teutonis. Speaking of, D. teutonis is the only species found in Germany and outside of North America in general, and it's the smallest known. Workers have speculated that its small size was due to the different environment it inhabited compared to its larger relatives. The larger North American species are found in wetter lowland deposits near to the coast of the inland sea, still covering much of western North America at this time. The Tambach Formation, however, preserves a much more arid mountainous inland environment where freshwater and plants, and therefore amphibians and large herbivores like Adaphosaurus, were less plentiful. This lack of large prey may have contributed to the small size of D. teutonis. The coloration looks quite similar to some colomorphs of green iguanas, though does anyone else think the pink around the mouth kind of makes it look like it's wearing lipstick? I think it makes tiger sounds too. Something else I feel is interesting to note is that amniotes were already apex predators by the end of the Carboniferous, as seen with the Ophiachodontids. We see a female Dimetrodon growl at the camera because monsters, and perform a mock charge to spook the Adaphosaurus herd and isolate weaker members. They respond by pumping blood into their sails, revealing a false eye spot intended to distract potential predators from their vulnerable heads. Interesting that the sail doesn't turn red, considering they were going for the highly vascularized portrayal, like the Stegosaurus's plates in Walking with Dinosaurs, which funnily enough is also no longer thought to have been possible. Whilst it's a really cool and plausible bit of speculation for the time, it's not thought to be likely now. Their bluff doesn't work, and the Dimetrodon homes in on a youngster with a whole lot of shaky cam. As was foreshadowed earlier, the predator bites the young herbivore on the head to kill it. We then get an anatomical shot of the inside of Dimetrodon's mouth. This is what gives Dimetrodon its name, 2 measures of tooth, as it had both incisors at the front of the mouth as well as serrated canines, though these weren't known in all species. In fact, only the largest species had serrated teeth. A paper published in 2014 suggested that growing larger body size and stronger, sharper teeth were adaptations to biting into larger and stronger prey and increasing the lifespan of their teeth. We get a cool shot of blood streaming down the sail of the dead Adaphosaurus puppet. The female doesn't get to eat much, as aggressive male Dimetrodon arrive to claim the carcass. The narration claims that Dimetrodon will eat 90% of a carcass, even the teeth, but I don't know if this can be proven by the fossil record, as I don't know if we've ever found coprolites attributable to Dimetrodon, that is, fossilized dung. Speaking of, we see a male shaking the waste out of the Adaphosaurus's intestines and covering the camera in it because monsters, with the narration foreshadowing that Dimetrodon adults can't stomach dung. The female returns to her nest, a mound of earth and wood, Get used to seeing this digging animation, by the way, as they use it a whopping 4 times, each with a different filter. We see her lay bird or crocodilian-like hard-shelled eggs. However, a paper published in 2012 suggests that early synapsids likely laid leathery, soft-shelled eggs, similar to those of modern monitory mammals. More vulnerable to drying out than those with a hard shell of calcium carbonate, these may have been kept moist by a fluid secreted from glands in their skin, precursors to the mammary glands and milk in true mammals. Whether Dimetrodon specifically had this supposed adaptation is made especially unclear by the 2025 paper showing D. teutonis' underbelly was covered in tough scutes. Perhaps they kept them moist in other ways, such as with damp vegetation like some modern reptiles and the platypus do. The narration also states that Dimetrodon eggs take 7 months to hatch, but there's no way of knowing this as of now. Watching the brooding Dimetrodon from behind a tree is another animal only referred to as an amphibian. This animal is ID'd as the genus here in the complete guide, and would you believe it's also not actually a true amphibian. It is named after Seymour, Texas, near to where it was first discovered, and also lends its name to the group Seymuriomorpha. They were a group of basal tetrapods, but where exactly they belonged relative to both true amphibians and amniotes has been a matter of debate since Seymuria was first described in 1904. In the 1950s, juveniles of the Seymuriomorph Discosauruscus from late Carboniferous and early Permian Europe were found to have an aquatic larval stage with external gills like tadpoles. They most likely represented a kind of transitional form from the ancestral amphibian style of reproduction to the derived amniotic egg. Seymuria baylorensis is known from both the Tambak and Arroyo formations, and this model looks basically perfect, and it has a really nice warm brown coloration with mottled cream coloured spots. I'm just surprised they added it at all, to be honest, as there's only 3 shots of it, 2 of which are reused, and it's basically inconsequential to this segment story. I'm also pretty sure it makes goose sounds. As autumn turns to winter, snow falls across the land. The omnibus cut has an exclusive shot, and I think I know why it was removed from the episodic cut, as you can see a person just strolling by in the background. Or maybe it's Bigfoot in a coat. When winter eventually turns to spring, the omnibus cut has an exclusive scene of a Dilophosaurus feeding on conifers, with the narration stating they contain an early form of antifreeze to survive through the cold winter, and that they have especially tough needle-like evergreen leaves. It also states that Dilophosaurus are among the first animals to evolve teeth for feeding on tough vegetation. The name pavement lizard even refers to its teeth, which were clustered closely together, making them resemble pavement. Something interesting to note is that years later, in 2018, a newly discovered genus of Adaphosaurid was described from early Permian sediments in New Mexico, and named Gordodon. Its teeth were indicative of a herbivore that browsed on softer plants, showing that the Adaphosaurids were specialized for a variety of diets and niches by the Permian. Later still, in 2023, another Adaphosaurid called Melanodaphodon was described from late Carboniferous sediments from Ohio, dated to roughly 315 million years ago, making it the oldest known member of the family. It showed a very unspecialized dentition, speculated to have been an omnivore, feeding on soft plants and insects. At the nest, we see a rival female Dimetrodon trying to take over the resident mother's nest. Something cool I only noticed recently is that the intruding female has a unique colour palette, as it has what looks like an orange scar on her face, whereas the resident mother has black markings. We then see a cool fight scene between the 2 Dimetrodon that goes on through the night, with more day-for-night filming. The next morning, we see she's managed to see off the intruder, but lost an eye in the process. We see young Adaphosaurus playing in the heat of the day, whilst the mother Dimetrodon lays weakly near her nest. A male Dimetrodon appears to be breaking into her nest, but likely unintentionally saved her brood, as he seems to have caught and killed the Seymuria as it was about to feed on the eggs inside. As he carries off his prize, the mother hears her chicks chirping and they start to hatch. Unfortunately, the young Dimetrodon don't get their own model and are just shrunken adults, and so the proportions are likely wrong. We don't have any juvenile Dimetrodon fossils, but based on how modern animals develop, they likely wouldn't have been born with their huge sails fully formed within the egg, especially if they're now thought to mainly be for sexual selection, so they may not have needed the huge sails until they reached sexual maturity. If the modelers and animators were presumably under time constraints, I honestly would have preferred that the young Dimetrodon got their own unique model rather than the Seymoria that is inconsequential, despite how good it looks, but that's just me. As the babies hatch, they immediately run for their lives as adults emerge to eat the unwitting babies. We don't know whether Dimetrodon was cannibalistic, but it's very possible. We see one run into some dung to deflect a pursuing adult, which was cleverly foreshadowed earlier. This buys the baby enough time to escape by running up a trunk. Again, no idea if young Dimetrodon could climb, but I think it's at least possible. It's then revealed that the adult is the mother, with the narration claiming she will weed out the weaker hatchlings to improve the odds of survival for the stronger ones and her species as a whole. The early Permian segment and episode 2 ends with Dimetrodon evolving into a Therapsid, a more derived group of synapsids. From this point forward, the starting creatures in the evolution sequences are different to the ending creature of the previous sequence. In this case, the previous sequence's ending creature was Adaphosaurus, but this one's starting creature is instead Dimetrodon. I'm not sure why exactly they changed this for the last few when the show had so far been, roughly, following humanity's closest ancestor each time. Speaking of which, Dimetrodon was not ancestral to any later synapsids. It, and in fact many of the more basal synapsids, became extinct around the start of the Middle Permian around 270 million years ago, thought to have been outcompeted by other, more derived synapsids that had branched off from them in the early Permian and had been evolving alongside them. If the show were to continue with the evolution sequences featuring only humanity's closest ancestor at the time, a better candidate would likely be the genus Shashajaya. It is thought to be a somewhat transitional form from the more basal, sail-backed pelycosaurs, though this term has fallen out of favour, and the more derived therapsids. It was found in the Halgaito Formation in Utah in sediments dated to the Permo-Carboniferous boundary from roughly 303 to 290 million years ago. It wasn't described until 2021 though, long after the show was released. So overall, I think the early Permian segment is quite good, though I do think it maybe relies a bit too much on Dimetrodon and its popularity, as it gets by far the most screen time. I think the omnibus cut of this segment is definitely superior, as it gives Adaphosaurus and the early conifers more screen time, and grants the viewer more context by fleshing out this segment just a little bit more than in the episodic cut. This segment is essentially the fauna of the Arroyo Formation of Texas living in the environment of the Tambach Formation in Germany. I can only assume this was done to avoid having 3 sequences in a row set in North America and seeming too America-centric, but I don't think it can be helped that so much informative fossil material has been found there. If it were to be remade today to be more accurate, it could be set 290 million years ago in Texas instead, as this way Shashajaya could be featured in both the starting and ending evolution sequences instead of Adaphosaurus and Dimetrodon respectively. It would only need to be moved from nearby Utah. Seymoria's role could be replaced entirely by Shashajaya in fact, if sticking only to 3 creatures. The narration could be corrected by having it refer to Adaphosaurus and Dimetrodon as either synapsids or stem mammals. The scenes involving the highly vascularized sails could maybe be replaced with a kind of courtship dance, or males competing to impress females with their sails. You could also update the eggs and nesting behaviour of Dimetrodon to fit our current theories. If the settings be moved to Texas as well, a different filming location may be required with a wetter climate. Like episode 2, episode 3 starts with a montage intro sequence summarising the first 2 episodes and teases what is to come in this one. We see Dimetrodon erroneously evolving into a Therapsid over 30 million years, or should it be 32 million years, into the late Permian. The evolution sequence shows the date 248 million years ago, which is most likely an editing error, as the following on-screen stats set this segment 250 million years ago, which is itself in error, as both would be in the following early Triassic period. Sadly, we have geographical and chronological issues yet again. This segment is somewhat based on fossil finds from the Silurian Formation in European Russia, close to the western side of the Ural Mountains, though once again, put a pin in that for now. The stats state that this segment is set in Siberia, which today encompasses the Asian portion of Russia east of the Ural Mountains. By the late Permian, Pangaea had drifted north to a point where it stretched from pole to pole. The landmass comprising most of what is today Eastern Asia was separated from the rest of Pangaea by a shallow inland sea connecting the Paleotethys to the Paleozoic. If this is intended to mean Russia generally though, it's fine I guess. It's just weird that they didn't just say Russia instead of Siberia, as they're not the same thing. The global temperature stat states that they were apparently 60% hotter than today, and the hazard stat lists extreme heat and volcanic activity, and these are all pretty accurate, as the second half of the Permian was subject to considerable volcanism. This was thought to be from the massive eruptions of the Amatian Traps, huge flood basalt eruptions that occurred from 262 to 259 million years ago at the South China Block, which at the time straddled the equator. It's still unknown what caused these massive basalt eruptions, be it an oceanic plate subducting under the South China Block or an unpredictable mantle plume. What is known is that they released huge quantities of volcanic gases into the atmosphere, causing massive global warming, melting the Gondwanan glaciers entirely, and ending the late Paleozoic Ice Age. The sediments of the Silurian Formation preserve an arid inland environment with very little plant cover and lakes that would frequently dry out, possibly due to being within the rain shadow of the central Pangaean Mountains in the northern hemisphere. This segment was filmed in the sand deserts of Fuerteventura in the Canary Islands, and it is an excellent representation of the environment at the time. The evidence of drying lakes is even integral to this segment's story. With that said, based on the animals seen in this segment and the narration, this segment should probably be set 256 million years ago instead, but we'll get into that more later. The narration states that all of the Earth's continents have merged to form Pangaea, despite the fact Pangaea formed back in the Carboniferous and had been in existence for about 80 million years by this point. It's really weird the show waited until now to mention it. It also states that its centre houses the largest desert the Earth has ever seen. Whilst I don't think that's true, the central Pangaean desert was indeed huge, due to its distance from the ocean, covering vast swathes of what are today the Americas, Africa and Europe. The narration states that in such a harsh desert environment, animals have to be especially tough, and that's perfect for reptiles. Whilst I'm pretty sure it still means to refer to amniotes when it says reptiles, we're introduced to an actual reptile, Scutosaurus. Its name means shield lizard, and it was a type of pariasaur, part of the larger group Parareptilia, thought to be the most basal of all reptiles, originating back in the Carboniferous. The narration describes it as a distant ancestor of turtles. This theory was based on the fact both pariasaurs and turtles are anapsids, animals whose skulls have no additional holes to the orbit, and that their skull armour was a precursor to the turtle shell. However, in 2015, 2 papers were published casting doubt on this hypothesis. One described the Triassic Age stem turtle, Papochelis, which was very different to pariasaurs, and the second performed a genetic analysis of turtles and other living reptiles, which showed that turtles were most closely related to crocodilians. The similarities between turtles and pariasaurs like Scutosaurus are therefore most likely the result of convergent evolution. Pariasaurs are named for their distinct large cheekbones, the parietals, and Scutosaurus also had a small horn just behind its nostrils, both of which are correctly reconstructed on this model. Their bodies were also covered in thick osteoderms. Unlike most reptiles, Scutosaurus's legs were not held in a sprawling posture. How straight the legs were held is unclear. This model has quite an upright posture, whereas many other reconstructions I've seen have a more semi-sprawled gait. I'm not sure which is the best supported as of now, so I'm not going to critique it. Scutosaurus was one of the largest pariasaurs at around 3 meters long and weighing around a ton. The proportions all look correct though, and the texture looks fantastic. The coloration is a simple yellowish brown, but fits perfectly with their desert habitat. I do like the little red and brown swirls behind the eyes. Overall, whilst it's not thought to be related to turtles anymore and the posture is uncertain, this model is an anatomically perfect Scutosaurus, and I think it makes horse noises mostly. We see an old male that's become separated from his herd, with the narration giving some pretty foreboding foreshadowing that the dunes hide a deadly predator. The old reptile makes a run for it, and we get small glimpses of the predator hunting him. There's a really nice heat haze effect on it as it runs across the sand in pursuit of its quarry. This is the animal Dimetrodon was erroneously shown evolving into, a Gorgonopsid. I'm not sure why exactly they didn't ID it by a genus in the show, but the complete guide specifies it as Gorgonops. Its name means Gorgon face, after the Gorgons from Greek mythology, known for their terrifying appearance in older depictions. Gorgonopsians were a kind of therapsid, a group of synapsids that evolved from more basal forms in the early Permian. Gorgonopsians were the first predators to have saber teeth, a trait some true mammals would later evolve independently, such as the saber-toothed cats. This female is shown to use her sabers in a manner similar to what's speculated for the cats, biting the neck to sever the windpipe. It's quite a gruesome death actually, as there's a fair bit of blood and you hear the Scutosaurus wailing in agony a lot before it dies. It then seems to menacingly almost do an evil laugh at the camera because monsters. So regarding the animals featured in the late Permian segment, only Scutosaurus is actually known from Russia. Gorgonops and 2 other animals we'll see in a bit are known from the Cysticephalus assemblage zone within the Karoo supergroup in South Africa. The Karoo is the undisputed richest source of Middle and Late Permian land animal fossils in the world, and considering how much this segment takes from this locality and how paleontologically informative it is, I'm surprised they didn't just set this segment in South Africa outright and instead change Scutosaurus to another pariasaur, which are also known from there. The narration claims that this female Gorgonops is 5 meters long, which is considerably larger than any known fossil specimens, of which the largest species was only 2 meters long. In fact, it's larger than even the largest known Gorgonopsid genus, Inostrancevia, which was 3.5 meters long. I'm not sure why exactly they made these ones so huge, other than to make them more imposing and exciting, I guess. I wonder if they felt pressured to do this, as otherwise it would be the only animal featured in the evolution sequences that was of similar size, if not smaller, than the starting creature, as Dimetrodon grandis was as long as Inostrancevia and bigger than Gorgonops, and might have risked it not appearing as impressive as the older and inferior animal as Monsters tends to present it. If this is what they were doing, they cleverly worked around this seemingly self-imposed restriction with Hynerpeton and Petrolacosaurus by using their eggs instead. It's also really weird that they modelled it after the South African Gorgonops to then scale it up and move it to Russia when the largest Gorgonopsid was known from Russia and was a contemporary of Scutosaurus. Granted, Inostrancevia is quite differently proportioned to Gorgonops as it's more heavily built, but still. Perhaps that's also why they didn't ID it by genus in the show, or maybe it was originally planned to be set in South Africa, but it was changed to Russia partway through production. This is all just speculation on my part though, obviously, but it might explain some of the decisions made during production. The narration then goes on to say nothing will rival her until the dinosaurs evolve in 30 million years, even though the oldest known definitive dinosaurs appeared about 20 million years later, potentially even earlier in the Triassic. So not only does it contradict the narration from New Blood, it also ignores the other large carnivorous reptiles that evolved in the Triassic, like Postosuchus, also seen in New Blood, and even another creature we'll see later in this show. It's been debated whether some therapsids like Gorgonopsians had hair. Their snouts are covered in foramina, small holes that house blood vessels. In reptiles like lizards, these supply blood to their lips. In mammals like cats, they support hair-like whiskers. Monsters goes for a plausible approach of them being scent glands that can secrete a fluid other animals can smell, as other extinct therapsids are known to have glandular skin, such as Estomenosuchus from Middle Permian Russia. They cleverly film it so that you don't actually see the fluid coming out of the model's head, and instead it's just there when it raises its head. They may have also had lips, so it's interesting that they chose to reconstruct Gorgonops with exposed teeth. So overall, it's a really good model, but the finer details miss the mark a little bit. I do love the mottled brown pattern it has though. The narration states that the reptiles, quote-unquote, biggest battle is now with the elements, as a massive surge in volcanic activity is superheating the atmosphere. This is likely referring to the eruption of the Siberian traps, which would occur 252 million years ago and end the Permian and Paleozoic era as a whole, and cause the Permian-Triassic mass extinction, the largest extinction event in the history of the planet, colloquially known as the Great Dying. Similar to the earlier Amatian Traps eruption, this eruption is most often thought to have been caused by an unpredictable mantle plume, causing massive quantities of liquid lava to erupt from cracks that form in the Earth's crust as it rises to the surface from the Earth's mantle. So it's odd that the show features footage of a more typical conical volcano. We see the female Gorgonopsid arrive at a small waterhole in the vast sea of sand. Other smaller Gorgonopsids give her a wide berth, with some excellent blending of CGI and reality as they splash in the water. Living nearby the waterhole are the next creature, Diictodon. Its name means two weasel teeth, referring to their distinct tusks. It was a dicynodont, an extremely successful group of herbivorous therapsids that flourished in the Permian, and Diictodon in particular accounts for roughly half of all Permian vertebrates found in South Africa, suggesting it was one of the most successful animals of its day. Their signature trait was their two tusks, the purpose of which is unclear. They were only half a metre long and had a semi-sprawled posture. Here we see several Diictodon living in burrows within close proximity of each other, and this is actually preserved in the Karoo. Their fossils have been found in shallow corkscrew burrows, several of which can be found in close proximity in the Karoo, but don't connect to one another. It's thought that they lived near floodplains, and sometimes the floodwaters would rise high enough to flood their burrows, sadly drowning them, but preserving their remains perfectly, with the sediment the floodwaters carried with them. They're often found in pairs, indicative of them forming mated pairs. Preserved within the terminal chambers of their burrows were nests, and it's quite possible the fathers also played a role in rearing the offspring. This model looks to be essentially perfect, except for one small detail. There are two morphs seen in Diictodon, one with tusks and one without. It's often assumed that the tusked morph represents males and the tuskless ones are females, but here all the Diictodon have tusks. We get an anatomical shot of their ear bones, and Diictodon did actually have simplified jaw bones that were instead utilised for hearing, and were possibly a kind of precursor to the middle ear bones seen in true mammals, derived from jaw bones. Probably owing to the wealth of specimens we have of these animals, we know a lot about Diictodon, and this reconstruction reflects that wonderfully, ignoring the fact that they're apparently in Siberia. Plus, they're just adorable and funny, a stark contrast to what is a pretty bleak segment otherwise. The narration also states that true mammals won't appear for another 30 million years, but they likely didn't appear until the Jurassic, so closer to another 100 million years. The burrows act both as shelter from predators and the desert heat, as they remain cool during the day. We see some Diictodon foraging the desert plants, which are presumably all plants native to Fuerteventura, but they might be meant to represent some kind of peltospermales, a completely extinct group of seed plants that first evolved in the late Carboniferous and lived until the early Jurassic, with some members suggested to be the first known plants to be pollinated by insects in a paper published in in 2022, based on early Permian scorpion flies with long mouthparts found in Russia. We see two Diectodon come into conflict over scraps, and what for them is a fierce battle over resources, to us looks like a funny squabble like with some modern animals. One also sniffs the camera, and I feel like this is one of the understandable interactions the creatures have with the camera, as the Diectodon are presented as more comedic. The Gorgonopsid comes to investigate, and similar to modern ground squirrels, they make an alarm call upon spotting the predator and retreat into their burrows. The Gorgonopsid then proves to be unsuccessful at whack a Diectodon and decides to rest and wait for larger prey to come to the waterhole to drink. Within the waterhole, we see what the narration calls a giant amphibian labyrinthodont. Man, what is this show's obsession with not properly naming amphibian-like creatures? At least this one is actually an amphibian. Or at least it is according to most studies. The complete guide IDs this animal as Rhinosuchus, only on the Coolosuchus's page though. The name Rhinosuchus means rasp crocodile, after the ridged surface of its skull, and it likely lived similarly to crocodilians as a semi-aquatic ambush predator. It was a temnospondyle, an extremely diverse group of tetrapods that are most often included in the class Amphibia, but outside modern amphibians of the group Lissamphibia. Temnospondyls first evolved in the early Carboniferous, and this might be what the narration is referring to when it describes Rhinosuchus as a fugitive from when this desert world was lush and green. Or it could just be that this particular area was more lush in the more recent past. It's been given horizontal slit pupils, which are seen in many modern amphibians, which is cool. Labyrinthodont is an outdated term for tetrapods that are not amniotes or true amphibians. So that just makes it even more confusing that they refer to it as an amphibian labyrinthodont. Perhaps its name was also an attempt to anonymize its identity for the show, if the setting hadn't quite been decided on. Both the CGI model and the puppet look fantastic and spot on to the known fossils. With all that said, whilst I understand it's meant to symbolise the dominance of amniotes after the Carboniferous, its portrayal maybe unintentionally sells amphibians short. Whilst they were no longer the dominant land animals by the late Permian, temnospondyls remained extremely diverse in aquatic ecosystems and continued to flourish until the following Triassic period, not to mention amphibian diversity today, but I understand what they were going for narratively speaking. This female attacks a Gorgonopsid out of sheer desperation and quickly retreats into a drying waterhole. The narration states that the waterhole has supported generations of labyrinthodonts, but that she is the last. I'm not sure if it means she's the last in this waterhole or the very last of her species, known as an endling. The wet season then arrives, but there's no rain, and the waterhole has shrunk down to the size of a puddle, and a Gorgonopsid watches the Rhinosuchus as the water dries up. We see Diectodon digging deeper to escape the desert heat, with one kicking dirt in the face of the other. The ground then shakes as a herd of migrating Scutosaurus arrives. I don't know if Scutosaurus were migratory, but I feel like it's plausible considering how scarce vegetation likely was in its arid habitat. I wonder if this is the same herd the old male at the start got separated from. We then get an anatomical shot of inside a Scutosaurus' stomach, where we see stones they've swallowed to act as gastroliths to help grind up the tough desert plants. While some modern birds use them, and some plant-eating dinosaurs have been found preserved with them, as far as I know, no Pariasaur has been found with evidence of gizzard stones, but I imagine they would have helped. The Gorgonopsids keep their distance, as even they dare not attack a herd of armoured Scutosaurus. Interestingly, one Gorgonopsid is seen resting with their hips twisting to the side, like modern cats sometimes do. This is possible due to the ribs forming a distinct chest region, allowing the posterior to twist relative to the front of the body. This also provides room for the thoracic diaphragm for breathing, something unique to mammals. In more basal tetrapods, the ribs extend all the way to the hips. In Gorgonopsians, it can be observed that their ribs start to shrink towards the hips, so it's possible they either had an early form of diaphragm, or maybe this was an adaptation for something else. This is impossible to prove though, unless we find some soft tissues preserved. Within only a few days, the Scutosaurus herd drink the waterhole dry and move on in search of food and water once again. The Gorgonopsid attempts to dig out the Diectodon, but their burrow is far too deep to reach them. She picks up the scent of something at the dried up waterhole. She finds the Rhinosuchus wrapped in a mud cocoon in a state of torpor, a last attempt to sit out the drought. Lines of arrested growth found in the fossil bones of Rhinosuchus indicate it underwent periods of stress during its growth, suggestive of an ability to suspend its growth like this in times of hardship. So this may be supported by the fossil record, which is really cool. The amphibian is helpless and the carnivore feeds. A sandstorm then hits the area and covers the waterhole completely. We see the Gorgonopsid mummified by sand, which is done with a desiccated looking puppet, which is cool. I like how it shows that even the fiercest creature can't avoid this extinction. The narration states that the vast Pangaean deserts continue to spread, and over the next few million years, the Earth will suffocate under a stagnant blanket of heat, sparking a mass extinction even greater than the one that will destroy the dinosaurs. If the Permian-Triassic mass extinction was indeed caused by the eruption of the Siberian traps, the volcanism would have increased global temperatures and caused more widespread drought due to an enhanced El Niño-like weather phenomenon. Volcanic gases would have caused acid rain, killing off vast areas of plants, which had a domino effect on plant eaters and then meat eaters. It's possible these were so severe because Siberia was home to a large coal deposit. This may have further released more noxious gases in the eruptions. Diictodon survived the drought thanks to their burrow sheltering them from the sandstorm and from uncovering underground plant tubers that contain water that keep them going for several months. The segment ends with Diictodon evolving into a larger Dicynodont over 2 million years. Diictodon wasn't ancestral to any other Dicynodonts, and despite what the show may imply, actually died out in the Great Dying despite its abundance in the Karoo. So overall, I really like the late Permian segment, though I think it's a bit messy in its execution. Because of the setting of 250 million years ago not actually being in the late Permian, and the narration stating that the extinction will occur over the next few million years, the timeline of events is very difficult to discern. The main extinction pulse of the Permian-Triassic mass extinction is dated to 252 million years ago, at the very end of the Permian. But it's heavily debated how long the volcanism and its effects went on for, so I'm not sure when the best time would be to set it at. Regardless of how long the extinction went on for, 250 million years ago is too late of a date for the late Permian. There's also the matter of confusing geography. The environment for both late Permian European Russia and South Africa was very similar, so they could have just picked one and ran with it, but instead we end up with this weird mix. If it were to be remade today, I think there's essentially two approaches you could take. The first would be to replace the Karoo animals with reps from European Russia. Gorgonops could be replaced with the larger Gorgonopsid Inostrancevia, like we said before. Diixodon could be replaced by the similar small Dicynodont, Elf, and Rhinosuchus could be replaced by the Temnospondyle Vinosaurus, though that animal was only a meter long and thought to have been fully aquatic, so may not be the best fit for Rhinosuchus' role in the segment. The second approach you could take, and the one I personally think works better, is to move the setting to South Africa 252 million years ago, and base all of the fauna on that of the Balfour Formation within the Karoo supergroup. Rhinosuchus can remain unchanged, and Scutosaurus can be replaced with its similar relative, Pariasaurus. Even though Gorgonops is native to South Africa, I think it would be more fitting to replace it with either the African species of Inostrancevia, I. africana, or another large South African Gorgonopsid genus, like Rubigia. Diictodon is an interesting one, as whilst it is native, it was not ancestral to the Dicynodonts seen in the evolution sequence. If the show were to keep having only humanity's closest ancestors be featured in the evolution sequences, at this time our closest ancestor would have been a kind of cynodont, like Cynosaurus. Cynodonts were the most derived group of therapsids in the Permian, and were one of the few groups to survive the Great Dying. Continuing on from earlier, it would be cool to have Shashajaya, the early Permian, evolve into Cynosaurus at the start of this segment and feature it somehow. It's also interesting that the Permian is the only period to get 2 segments dedicated to it, unless you count the Silurian segment as being the early Devonian. Not sure if it was intentional, but this allows them to make the transition from basal, lizard-like amniotes in the Carboniferous to the much more mammal-like animals of the late Permian more believable, with the more reptile-like sailbacks to bridge the gap, whilst also capitalising on the popularity of Dimetrodon. For the 7th and final segment of the show, Diectodon is seen erroneously evolving into a larger Dicynodont over 2 million years, into the first period of the Mesozoic era, the early Triassic, 248 million years ago. Ironically, it's this segment that should have really been dated to 250 million years ago, as most of the animals featured in this segment have been found in sediments dated to this time. This segment is set in Antarctica and is partly based on fossil finds from the Fremu Formation in the Transantarctic Mountains. The stats claim that the global temperature is 40% hotter than today, which could be a fairly accurate estimate, but due to the eruption of the Siberian traps, the early Triassic was actually even hotter than the late Permian. With that info in mind, as you might expect, when the narration then states that the deserts have stopped growing, it is incorrect. Geographically, the early Triassic was basically unchanged from the late Permian, aside from the expanded central desert. The Siberian traps continued to erupt until the middle Triassic, roughly 241 million years ago, but on a much smaller scale, though still large enough to cause further minor extinction events to the more vulnerable, unstable earlier Triassic biosphere. Due to much of the centre of the supercontinent being a scorching wasteland, most early Triassic fossils are known from regions that were closer to the poles at the time, as they were cooler and fostered more hospitable conditions. Whilst further north than it is today, the continent of Antarctica was still close to the South Pole, and this area was likely within the Antarctic Circle. Life here would have had to endure months of darkness in the polar winter, and months of constant sunlight in the polar summer. The sediments of the Fremu Formation preserve a temperate forest environment surrounded by rivers. This segment was filmed in La Palma and Gran Canaria in the Canary Islands. You may recognise these localities from Chased by Dinosaurs, Dragons of Fantasy Made Real, and 2 years after Walking with Monsters, Primeval. This location is fantastic, though not quite the best fit for the Fremu Formation, as the climate seems to be a bit too hot and arid. It's a better representation, however, for the environment preserved in the sediments of the early Triassic Lystrosaurus assemblage zone within the Karoo supergroup in South Africa. South Africa and Antarctica had been connected as part of Gondwana since pre-Cambrian times, so was relatively nearby to the Fremu Formation. Being further from the South Pole, South Africa had a slightly hotter and drier climate in the early Triassic than Antarctica. What's cool is that proof of their proximity is provided by the fossil record, as there's a lot of faunal overlap between South Africa and Antarctica at this time. It may be no surprise that all of the animals in this segment are known from South Africa. One of these animals was the prolific and namesake genus of the Karoo fossil assemblage zone, the Dicynodont Lystrosaurus. Its name means shovel lizard, and it actually first evolved in the late Permian, and is one of the few creatures that survived the Great Dying, so showing it evolving from Diectodon at the end of the Permian is a bit misleading, as it wasn't descended from it and was already around at the time. The reasons cited for its miraculous survival include its burrowing habits like other Dicynodonts, and most likely, a whole lot of luck. The surviving populations of Lystrosaurus would have emerged into an almost barren landscape at the start of the Triassic, and with the proverbial slate wiped clean, there was next to no competition for the recovering plants, and so their populations subsequently exploded. It's an excellent example of what's known in biology as a disaster taxon, an organism that flourishes after an ecological crisis. Not only were they plentiful, they were widespread, being found in Africa, Antarctica, India, and possibly Russia and China. Fossils like these were actually pivotal evidence for gaining support for the theory of continental drift in the 1960s, as these were fairly small land animals that could not have crossed the vast oceans present between these landmasses today, so the continents these animals lived and died on must have moved. As for the Lystrosaurus model itself, it's quite difficult to judge the accuracy as there are currently 4 accepted species of Lystrosaurus, and historically way more, but most of those have been synonymized with the 4 accepted today. Whilst they obviously have their slight differences, they're largely really similar and hard to tell apart from a glance. I've also seen conflicting information online over which species are present both before and after the Permian-Triassic boundary. I think this reconstruction is actually based on Lystrosaurus murrayi, known from both Antarctica and South Africa. However, it was around the same size as Diictodon, whereas this model is clearly larger. I imagine it's been scaled up to the size of the largest species, L. macaigi. I'm really not certain though, so if any of you could shine more light on this, please do let me know in the comments. Judging it as a generic Lystrosaurus, it has its characteristically flat face, the correct gait, and bodily proportions. Where the specifics are concerned, I'm not sure I can say. It looks really good though, and has fairly bland but naturalistic light grey coloration with faint stripes on the back. The narration claims that Lystrosaurus accounts for half of all life on Earth at this time, which, no. Simply, no. I'm sorry, but that is awful wording. From the fossils we have, Lystrosaurus accounts for over 90% of the biomass for land vertebrates in the early Triassic. Did it make up over half of all animals on land? Potentially. As big of a runaway success as it was, claiming it accounted for more than half of all life on Earth is just insane to me. I also don't know if it means in terms of abundance or biomass, or even if it just means on land or just animals. Even if we exclude single-celled life like bacteria, fish and zooplankton would likely have them outnumbered, and that's not even counting plants. I'm probably putting way too much thought into this. Let's just pass it off as very poor wording and move on. The narration claims that a rival is evolving in the forests. We are then introduced to the reptile Euparkeria. Its name means Parker's good animal, after zoologist William Kitchen Parker, and it was a close relative of the dinosaurs. However, it's likely not directly ancestral to them as the narration implies. It was a member of the reptile group Archosauriformes, which includes the archosaurs, crocodilians, pterosaurs, dinosaurs, and birds. Euparkeria could not be ancestral to dinosaurs, as it branched off before the ancestors of crocodiles and dinosaurs split from each other. It was still closely related to them, however. Anatomically, the model looks superb and has a beautiful coloration and texture. Most specimens average around 60 centimeters long, and it likely fed on small animals like insects, as showcased here when it eats a dragonfly that reuses the Meganeura model, though griffin flies died out in the Great Dying. It is portrayed as a primarily quadrupedal animal but a facultative biped. This is showcased with an anatomical shot of its hip bones that positioned its legs below its body, unlike most reptiles. Whilst this trait is most famously associated with dinosaurs and birds, there were in fact several Triassic reptiles with similarly positioned legs, but their hips were differently shaped. In Postosuchus, for example, the ilium, the upper hip plate, juts out to the sides, making the hip socket point downwards. Dinosaurs, however, had their hip sockets point to the sides, and their upper leg bones had a distinct head that pointed inwards towards it to slot into the socket. The practical hip and femur seen here look like the conditions seen in dinosaurs. A paper published in 2020 found that Euparkeria's hips look closer to the conditions seen in non-dinosaur reptiles with erect limbs, but the angle they connected with the hips suggested a semi-erect gait, similar to the crocodilian high walk. A paper published in 2023 found that Euparkeria's centre of mass was far in front of the hips, suggesting it was not well suited for walking on two legs and may have been completely incapable of it. Both of these studies also point to the idea that archosaurs attained erect limbs in a gradual, stepwise process and likely wasn't complete until after Euparkeria had branched off. Euparkeria also wasn't a contemporary of the other creatures in this segment. Whilst it was found in the Karoo of South Africa, It hails from the younger Bergersdorp Formation. These sediments may have been deposited 248 million years ago, but those containing some of the other creatures were likely older and may have died out before Euparkeria appeared. A paper published in 2011 examined Euparkeria's sclerotic ring, the ring of bones that support the eye in some animals, and found that they most closely resembled modern nocturnal reptiles and birds, suggesting it too was adapted to low light conditions, perhaps owing to South Africa's proximity to the South Pole at the time. So it didn't live in Antarctica or alongside the other creatures in South Africa, and its posture, time of activity, and ancestry to dinosaurs is outdated now, but the model looks stunning. It's kind of a tragic case for Euparkeria. With that said, the ancestors of dinosaurs at the time may have been very similar. There's actually a really cool leitmotif in the music for this segment that's the melody of Time of the Titans from Walking with Dinosaurs, foreshadowing the evolution of the famous reptiles. It's a little bit depressing that the most noteworthy piece of music from Monsters to me is the one that references music from one of the other shows. The narration states that the Lystrosaurus are forced to migrate due to their vast numbers eating so much vegetation, and that they mainly move at night. There's no evidence for Lystrosaurus being migratory, but considering how widespread they were, it seems plausible to me. They're forced to walk through a canyon in the dark, and their eyeshine with the night vision looks really good. The herd is being stalked by a Therocephalian. This was a group of predatory therapsids that survived the Great Dying, and may be ancestral to the cynodonts, which in turn are ancestral to us. Similar to the trilobites from the Cambrian segment, this animal is annoyingly not ID'd by genus name in any supplementary material. But I'm pretty sure it's at least somewhat based on Euchambersia, due to it possessing a venomous bite. Whether Euchambersia was venomous has been debated pretty much since it was first described in 1931. Unlike other Therocephalians, Euchambersia has a depression behind its canines, whereas others have teeth. CT scans showed that this depression was filled with canals that connected to the canine tooth socket. The canines, on top of being large and saber-shaped, also appear to have a ridge. These have been interpreted as a venom gland connecting to viper-like hollow fangs for injecting the venom when biting prey. As recently as 2017, there is still no clear consensus of whether this animal possessed venom, as if it did, it is very different to any other venomous vertebrate known. I don't think I can meaningfully critique this aspect of this animal until we have more clarity on the issue. What I can critique is the fact this model is pretty obviously a retooled cynodont from Walking with Dinosaurs. They've just made the body longer and given it saber teeth. I wonder if having this scene be at night was also to disguise the similarities more, as you never see it in daylight. Its torso and tail are too long, and the head isn't quite the right shape, probably because it's supposed to represent Thrinaxodon. I can also critique the fact that Euchambersia was actually a Permian animal, being found in the Dicynodon assemblage zone in the Karoo, dated to the end of the Permian. Therocephalians have been found in the Lystrosaurus assemblage zone, and one of them, Moschorhinus, was likely an apex predator and built more like a gorgonopsid. There was also Oliviarosuchus, which may fit this model better, though the proportions would still be wrong. Therocephalians are also known from the Fremu Formation in Antarctica, but none were large apex predators. I'm inclined to say this is the worst model in the show, just kind of by default, as it doesn't really look like a Therocephalian. The fact this is the only dud though speaks volumes about how stellar Walking with Monsters model quality is. When one bites a Lystrosaurus, the narration claims its venom is more potent than a black mamba, which I'm sure was written just to sound exciting and to give the audience a reference point with a modern venomous animal. Obviously, there's no way of knowing if it even had venom, never mind how potent it would be. The Lystrosaurus limps off to the side of the canyon as the others pass it by, as they have no social bond. It's kind of sad. We see multiple Therocephalians approach the kill, though I don't know if we have any evidence of them living in groups. I also don't know if they were nocturnal either. The next morning, the herd has to carry out the annual river crossing to get to the rich vegetation on the other side. Waiting on the banks are the final creature of the show, referred to as Chasmathosaurs. This is a really weird example of not referring to a creature by genus name. Chasmatosaur could refer to one of two things. The first is Chasmatosaurus, and the second being the family Chasmatosauridae. In 2015, Chasmatosaurus was synonymized with Proterosuchus, and because the latter's name was coined first, it takes priority. Because of this, Chasmatosauridae is more correctly called Proterosuchidae. What's so strange is that even before this paper was published, this creature was ID'd as Proterosuchus in the complete guide, so it's very odd that they chose to call them Chasmatosaurs in the show. Proterosuchids were a family of archosauriforms that branched off before the ancestors of crocodilians and dinosaurs split off from one another. So similar to how Euparkeria was not the ancestor of dinosaurs, Proterosuchus was not the ancestor of crocodilians. Rather, Proterosuchids and crocodilians independently evolved to fill the semi-aquatic ambush predator niche via convergent evolution. With that said, the aquatic habits of Proterosuchus have been questioned in various papers published from 2011 to 2020, as many aspects of its anatomy show conflicting adaptations to a semi-aquatic lifestyle. Its legs were rigid like a land animal, and its nostrils were on the sides of its snout rather than on top like in crocodilians for them to breathe with their heads mostly submerged. Yet its brain was similar in shape to that of crocodilians, but how reliable this is for determining its lifestyle is uncertain. So this entire sequence of them hunting Lystrosaurus crossing the river like modern Nile crocodiles may not be plausible. Proterosuchus is only known from the Lystrosaurus assemblage zone in the Karoo. There is a large indeterminate archosauriform known from the Fremu Formation in Antarctica, estimated at roughly 10 feet long, similar in size to Proterosuchus, and may even turn out to be a Proterosuchid, but this requires further study as of now. They walk with a semi-sprawled posture, similar to the crocodilian high walk. This seems plausible, though I feel like their legs are either too straight or too long, I can't quite tell. The model looks wonderful otherwise though, with their signature downturned snout, the purpose of which is unclear whether it was for holding prey or for social signalling of some kind. It's been restored with traits seen in crocodilians like vertically slit pupils, the thick scales seen on their tails, and lacking lips. However, if they weren't as aquatic as we once thought, they may have needed lips to stop their teeth drying out. So overall, it may not have hunted in the manner portrayed here, but it looks really good, both the CGI model and puppet. I really don't know why they're not just called Proterosuchus though. I love how the one walking behind in this shot nudges another's tail and they all react automatically like modern crocodilians. I also like that we see one basking and then chase after Euparkeria, even though this interaction likely didn't occur. The first Lystrosaurus successfully crosses the river and... wait, is that rock covered in bird poo, despite the fact they supposedly hadn't evolved yet? There is actually a behind the scenes photo of them filming this sequence in Gran Canaria, where Tim Haynes is attempting to make friends with a Muscovy duck. Was it you? Well, I guess it could be some other Triassic reptile that similarly excrete uric acid rather than... okay, no, I am not further analysing bird poo on a rock. Moving on. With the Proterosuchus eating their fill, the vast majority of Lystrosaurus make it to the other side of the river, with one bumping into and acknowledging the camera because monsters. The narration hints that as the world recovers from the Permian extinction, so does competition, and these newly evolved species will outcompete Lystrosaurus, bringing an end to their brief glory days. It's also possible Lystrosaurus became extinct due to another Siberian traps eruption 249 million years ago, in the, incredibly fun to say, Smithian-Spathian boundary event, which was also responsible for the extinction of many aquatic disaster taxa still clinging on from the Permian. We then see the Euparkeria return to the riverbank to scavenge on the Lystrosaurus corpses. This is actually supported by the fossil record somewhat, as a bone bed of around 50 Euparkeria is known, thought to have accumulated to scavenge on the desiccated corpses of animals that died in a drought, but themselves being killed in a flash flood. The Euparkeria then stands up to a Proterosuchus, with the narration foreshadowing that it will usher in a new age of the most notorious monsters of all, the dinosaurs. We then get a very fast evolution sequence of Euparkeria erroneously evolving into the Allosaurus from BBC's The Lost World from 2001, also animated by Framestore, before it then turns into Big Al for some reason from The Ballad of Big Al. I like how just for this one sequence, the Proterosuchus seems to react to this little creature morphing into a huge theropod. Maybe a bit cartoony, anachronistic, and anthropomorphic, but it's so cool looking I don't really care. Interestingly, the Omnibus cut shows footage of Coelophysis and the Cynodont from New Blood, even though Allosaurus is from the Jurassic, and it later shows footage from Big Al and Time of the Titans over the credits, whereas the episodic cut seems to have a totally original animated scene of a slightly green-tinted Allosaurus walking towards a pair of Stegosaurus on a backplate used in Time of the Titans, which is pretty cool. All the while, the music track Time of the Titans plays us out, bringing the Walking With series full circle. A wonderful note to end the best series of paleontology documentaries ever made, if you ask me. So overall, I think the early Triassic segment is good, but there's a few things about it that bug me. Like with the late Permian, I wish they had just set it in South Africa, as literally all the animals are from there, and making the setting Antarctica just feels arbitrary to me. I know I said they share a lot of fauna, but not all. If it were to be remade today, there's quite a few ways you could go about it to make it more accurate, but none would quite retain the story as it is. The simplest would probably be to set it 250 million years ago in South Africa, replace the Diictodon in the late Permian segment with a Permian species of Lystrosaurus, and either have it evolve into a Triassic species, or have the evolution sequence instead be more like a time-lapse sequence occurring around it as the world changes. That could be a cool idea. This would be a very rare example of life on our planet exceeding Walking With in some capacity. Also, give the Therasophalian its own model, so it's not just a stretched out Cynodont. Ironically, our closest ancestor at this time would be something similar to Thrinaxodon, which was known from this place and time, and is oddly enough what the Cynodont in New Blood was originally based on. So if the show kept going with our closest ancestor as the focus, that could either be included or replace the Therasophalian and remove the night hunting scene entirely. Come to think of it, if Antarctica was still within the Antarctic Circle at this time, how could they have regular nighttime hours? Proterosuchus could remain, but if it wasn't as amphibious as we once thought, the river crossing scene could maybe instead be fulfilled by a temnospondal amphibian, but I appreciate that thematically, the show has been phasing amphibians out up to this point. That just leaves Euparkeria. The closest thing we have to an ancestral dinosaur for this time is a possible track maker for the ichnogenus Prorotodactylus. It has been variously suggested to be the footprint of a dinosauromorph, a larger group including true dinosaurs, or an animal like Euparkeria. Prorotodactylus tracks are presently only known from Poland and France, but Pangaea meant that animals could feasibly get anywhere, so I don't think it's out of the question that this track maker could have been in South Africa also. Wow. I was not expecting this video to be as long as it ended up being, but there was just so much to cover, and the fact Walk With Monsters spans the entire Paleozoic era, not to mention some pre-Cambrian and early Mesozoic stuff too. So many studies have been carried out and published since the show was made, some of which completely uproot what was shown. Overall, I think Walking With Monsters is another fantastic inclusion into the Walking With series, and an excellent send-off as the final installation. These don't count. With that being said, of the main trilogy, Monsters is definitely my least favourite, as I just much prefer the style and structure Dinosaurs and Beasts have. I still think Monsters is a well put together show, and an incredibly high quality documentary of the Paleozoic. I just feel it lacks the majesty that Dinosaurs has, or the fantastic storytelling of Beasts. It certainly has its own charm though. I just happen to not be a huge fan of the constant fourth wall breaking, but that's just me. I can absolutely see people vibing with this style and approach more than me though, and I'm really glad for them. I think the best thing about Monsters is the effect, as even 20 years down the line, they still look state of the art, and Framestore were second to none when it came to animating extinct animals for TV. Crawly creatures' puppets and animatronics are also superbly sculpted and detailed. Even if some depictions are very outdated now, for the time and even still now for the most part, the model designs are stellar for monsters. I guess since I did this with the other two, I'll rank the 7 segments from the ones I enjoy least to most. In 7th, it's the Cambrian. It's just very simple, with the Anomalocaris eating a trilobite, getting injured by Agon specific, and getting scavenged by Hycoichthyes. Plus, I'm still bitter they didn't even name the trilobite. In 6th, I went for the Silurian. It's a mess scientifically, but I definitely enjoy it more than the Cambrian, and I think it's cool they made a practical Cooksonia plant and Brontoscorpio exuviae for when the Cephalaspis migrate inland. In 5th, I actually went for the early Triassic. I was quite shocked by how low it was, but yeah, it bugs me, but it's still very well done, and minus the Theracephalian, the creatures are all great. In 4th, I have the early Permian. I think the story for this one is one of the better ones, but I think the Dimetrodon gets a little bit too much focus for my liking, and the Seymoria could basically be removed. The Edaphosaurus are wonderful though. In 3rd, I have the Devonian. I love both the Hynerpton and Hynerian models, and they really sell this one for me. It's very simple, but I think what it does spectacularly. I still don't know what Stethecanthus is doing there though. In a very close second, I put the late Permian. This one was my favourite as a kid, and I still think it's excellent. All the models look awesome, and the Diectodon are just mwah, chef's kiss. And for my number 1, I shockingly went for the Carboniferous. Is it a mess scientifically? Yes. Does that hinder its quality? No. The story is really well done. The models, as dated as some of them are now, look awesome, and I just really like it. Simple as that. These aren't objective quality in any way, shape or form. They're simply based on my own personal enjoyment. Which segment's your favourite? And what do you think of Walking with Monsters in general? Let me know in the comments below. I've been reviewing the Walking With shows for 6 years now, and enjoying them for over 20. It has been such a pleasure to revisit what are, in my opinion, the best paleontology documentaries ever made, and to share it with all of you. I cannot thank you enough for watching and listening to this nerd yap on about shows from 2 decades ago, about things that are way older than that. Thank you all so much for watching, and please do like, comment and subscribe, as it helps a ton. Bye bye now.